أساس مطفي ليش اشتغل؟ إيه تفضل قل لي. هون في شيء عندنا هون في شيء عندنا؟
لا بس إنك تغير.
أنت من عندك تتحكم فيه كأنه؟
لا التحكم وين؟
إيه خليه معه. لا أنا بدي أتحكم
لا أنت لأنك أنت راح تكون تبرر كلامك مع التشينج الفلو.
أوكي. هذا الكلام بحكيه مع هون. بدي أرحب في بنزل اللي بعده مو هيك؟ موجود اللي بعده هون هو صورته.
شوف هلا هو الحين نص صار أنا.
أوكي.
طبعا أنت
قل لي
شلون؟
أوكي.
نرحب بالدكتور أمريكا.
لا.
هو جاي.
هذا بدي أحكي عنه لأنه في بايوغرافي بدي أحكي عنه. أوكي. أوكي. That's it. أوكي.
تحط عليه شوف.
أي زر تكبس أنت؟
هذا
يمين أو يسار؟
يسار ترجع يمين.
أوكي.
طيب تفضل.
إن شاء الله ربي ييسر. أون أوف.
هذا هو.
أوكي. أنا عملت برنامج دقيق بالكلام يعني إنه الساعة 9 شو بدي أحكي، الساعة كذا شو بدي أحكي مشان ما يتلخبط. كيف الأهل كيف الأهل.
طبعا دكتور كل واحد يجي عنده برزنتيشن هذا المايك.
إيه بيطلع الباوربوينت.
خلص.
وإذا كان فيديو بيطلع الفيديو تبعه.
أيا كان.
أوكي.
غير دكتور.
هذا شغال. أوكي. Thank you. ممكن هذا أحطه بجيبي. حطيته صار يصفي. حطيته بجيبي صار يصفي. لا هيك مطفي. حطيته بجيبي. اوكي. ثانك يو. اتس اوكي. يعني اسمه بصوت. We are waiting. ايوه كله راح. اوكي. جاهز البرنامج. هو نفس البرنامج اللي مسوي. خلاص بريك. تكنيكال سيشن. You are welcome. So, Professor, may I start? So, good morning, everybody. Good morning, our distinguished guests, speakers, and participants. Welcome to the final day of our conferences, ITSN or ATSN and ICTA 25, held here at the Kuwait College of Science and Technology. Today is a very special closing day dedicated to assistive technologies, digital accessibility, and human-centered innovation. These topics are truly represent, or these topics that truly represent the mission of our conferences. I am Dr. Engineer Abdul Latif Bagha, and it's my honor to serve as your session chair for this important final program day. Let me introduce our first keynote speaker today, the Professor Rohan Paul from Indian Institute of Technology. The keynote title is Infusing Human and Artificial Intelligence in Assistive Technology Solution. Professor Rohan Paul is a professor at the Department of Computer Science and Engineering, Indian Institute of Technology, Delhi. His research mainly in robotics and AI. He got a lot of awards in different international conferences like EROS and ICRA in different years, as he was nominated one of 35 global innovators under the age of 35 by MIT, Massachusetts Institute of Technology, USA. So please join me in welcoming Professor Rohan Paul here on the stage. Yes. Yes, it works. It works fine. I can click directly on this one to play anything, and this one is slide. Okay. Thank you. Good morning, everyone. It's a real privilege to be part of this conference. I express my sincere gratitude to Professor Khalid here for inviting us from all the way from India. I have recollections of Professor visiting our institute, and his infectious energy and enthusiasm and passion for this sector is remarkable. I am truly amazed by the developments henceforth in bringing this conference and building an ecosystem
in Kuwait that is extending to this entire region. So thank you very much. I'm deeply, deeply honored, and I bring greetings from my institute and from my country. So as a quick background, I work in the Department of Computer Science and Engineering with joint affiliations with the School of AI and the School of Information Technologies. So the work that you will see is a blend of all of these three different areas. And in particular, I would say that the work I'm going to talk about is in collaboration with Dr. Piyush Chanana and Professor Madhusudan Rao, who are both affiliated, and I'm also affiliated by the National Center of Assistive Health Technologies, now at IIT Delhi, with the mandate to develop novel solutions and take technologies to persons with disabilities. So we work in a wide range of technology development areas, and largely our focus has been on visual impairment, which includes the entire spectrum of print disabilities. But increasingly, as the world is becoming more inclusive in the disability world as well, we're now talking about universally accessible systems. So we are also now interfacing with other disabilities. So you see a reflection of that. And the particular topic that I decided to speak today and to discuss with you is something that everyone is talking about in their respective fields of study, which is AI. How do we work with AI? And what does AI really offer for persons with disabilities? And I'll look at blindness in particular. So I will talk about 2 or 3 efforts in our lab in using AI and share with you some of the lessons that we have accumulated over the years. But more importantly, I look forward to your feedback and your thoughts as well as to what AI can do for this sector and how do we see this future emerging. And my key finding is already there in the title, which is that AI in itself may be just a tool. It does require the human to work closely with the AI to really make it work. And that's been a lesson cross-cutting many of these projects, and I'll harp on and emphasize this theme as we move forward. Okay, so let's start with first principles. And as engineers, we like to define things. So how do we define AI? AI has various definitions. Anybody you would ask would come up with their own definition of AI, ranging from, well, this is something like ChatGPT, this is something like an image recognition system, so on and so forth. I would call this as a collection of computational technologies that have the ability to perform certain cognitive tasks such as recognition, decision making, and problem solving. So AI is a set of tools, it's a set of technologies, and that's how we teach it in our undergraduate class as well, that it's a framework, it's a collection of algorithms, it's a collection of techniques and mathematically grounded tools which allow machines to display capabilities that were traditionally thought of as only something that humans possessed. Recognition is the easiest one to understand. We work with devices that can understand our voice. We have camera-based systems that can recognize, so that comes very naturally to us. But the AI, which is also emerging, powered by things like reinforcement learning and many other aspects such as human feedback and so on and so forth, are also now taking AI into the realm of decision making and problem solving. We have seen incredible results such as ChatGPT is one, but if you also look at many other tools for scientific discovery, we are seeing that AI is also playing an important role in also in other areas of problem solving and decision making. Now the question is that as this AI is developing in our phones, in computers and so on and so forth, right? What does this mean for accessibility? Or what does it mean for persons with disability? So this list can be very large, but I would talk about 4 different aspects in which AI will have applications. Number one is that a lot of accessibility is about providing content in the right formats. Content conversion, let us say production of accessible books or image or captioning and those kinds of systems, are typically done manually. Now AI being the fundamental technology that can convert one modality to the other is bound to have an impact and accelerate that process. The second two areas are connected, which I am writing as AI guardians or trainers. Assistive technology requires a certain effort in order to adapt or adopt that into the day-to-day life. It requires very systematic training and encouragement, and the user takes some amount of time to actually learn how to use the technology. Now, if this is all dependent on human effort, then there will be people who would be left behind because we don't have that many trainers as well. And hence AI comes in again. AI can be some sort of a support for the special skill kind of a compensation, and try to present one example today. And finally, AI is also evolving, right? So today's AI, which is living in the academic community or in papers, is going to be in tomorrow's products. That means as AI researchers or accessibility experts, we should be also looking at frontier technologies to visualize products and applications of the future. And one of the areas that I'm particularly interested in is physical AI. That means AI which lives not just on the computer, but that lives on devices, or it lives in robotic technology. So with that as a overall framework, let's look at a couple of examples of using AI in the projects that we have explored in our lab. So we've been working on the problem of independent mobility for persons with visual impairment for a number of years. Starting from 2005, we've looked at this problem of how does a visually challenged person walk independently in unstructured outdoor environments. Each one of us would have seen a blind person use a white cane. They use this to tap on the ground and detect things in close proximity. Now, this particular cane-like device is incapable of detecting anything from knee till head height and has a fairly restricted range of about 2.5 meters, not beyond that. That means objects which are raised above the ground are likely to cause impact, that also unexpectedly, leading to both anxiety and also injuries in the upper body area. Now, in a country like ours, which is highly populous and has, it's been difficult to mandate infrastructural guidelines, objects are going to be, part of these roads, and things are going to be of this kind. So how do we compensate for this? So the idea that our lab has been working on is to combine this with low-cost sensing, which can be mounted on the cane itself, that emits detection cone. It emits waves, ultrasonic beam in this application, to detect things which are raised and then inform the user through vibratory patterns. Why vibrations? Because acoustically the person needs to be aware of the ambient sounds such as cars or people, etc. So we don't want to fiddle with that modality. We want to supplement their natural ambient sound awareness with something tactile, which is very subtle, and these vibrations are produced on the unit itself. This technology is right now in deployment, and here you see a person using this in real life. The first one is you would see a person walking on the side and then avoid this particular tree branch. This is trials in Bangalore, where the person is able to find a gap because you would have high vibrations on one side, lower vibrations in the middle, and then again high vibrations. She's also able to avoid this protruding window and not colliding with it and appropriately changing the direction. This is safe navigation of vehicles so that you're not colliding with them and be able to find a path appropriately. So a number of these applications have emerged for this technology, and today there are about 200,000 units in dissemination. That means they've been given out to users. It's a technology that has been incorporated into the national program of devices for the low-income strata. It's called Assistance to Disabled Persons in Purchase of Technology. It's a Government of India scheme. And these are all the various centers on the map of India where this has been distributed. Apart from India, it has also been introduced in 12 other countries and continues to expand in some way. The Honorable Prime Minister of India, Shri Narendra Modi ji, has been a supporter for persons with disabilities. The Hindi word is Divyangjan, And there are specific schemes for the Divyangjan under which, at one point of time, the Honorable Prime Minister distributed this technology in his own constituency, and he engaged with users as well. So what we are seeing here is a development of an end-to-end technology starting from inception in 2005 as a student project, much like the projects that I have been seeing in this conference. I see very excited students presenting their prototypes and their ideas, and that's how, along with my colleagues, I also started working in this technology. And then it has taken a lot of time to evolve this technology through trials, working closely with users, and finally working with industry, supported by certain funding from the Wellcome Trust and now recently ICMR, which finally transitioned that entire thing into a product. Now, in some sense, we have reached the completion of a technology cycle, starting from an idea to a product. So in that sense, the technology is, the cycle is complete. But the main problem is training. Now, as these devices go out, a lot of the time people will work with them or use them for a short time and then abandon them, right? Or they have so many questions that one is not able to answer that in a structured kind of a way. So what we started with was a large-scale dissemination program in which training the trainer workshops were conducted in every part of the most dominant parts of India, the major states. So trainers would come, we would train them. There would also be users themselves who would come and receive training. And that's how the knowledge of how to use this device with the sensing and for this vibration output effectively has been disseminated to a certain extent. But it turns out that if you just look at India, the blind population or the population that requires this kind of a technology is at least 10 to 20 times the numbers that we have been able to reach. So the question is, what is this gap and why this gap is arising? The gap is arising largely because of the ability to train effectively, right? Because for a person who's not used to vibrations, who's not used to technology, not used to sensing, it's magic. And it becomes very difficult for them to adopt or change their lifestyle, to do this behavior change later on in their life. And hence, it is now very clear to us that the focus of technology introduction and training must happen at a much younger age. And hence, now the effort has changed towards not just looking at adult population, which is fine and we can continue to do that, but how do we bring that back to young people? How do we bring this back into schools? When the child's brain is developing, when their locomotor skills are developing, how do we intervene at that stage? And hence, instead of talking about just creating a technology and training, can we construct technology only for training and for appropriate use? So with that motivation, in order to teach a blind person to use the cane, you essentially need to look at two parts. What is the angle at which they are holding it? Is this correct or not correct? And what is the extent of their lateral tapping? If you can characterize that, then you can give feedback to the person who's trying to learn. Imagine a child, let's say 4 to 5 years of age, who's trying to learn. Now, what we can do here is to embed AI to assist in this process. So what you're seeing here is the same unit, but this has now IMU data coming in. So there are inertial measurement unit, very small inertial measurement unit, which is inside, which has the capacity to look at angular accelerations as well as linear motions as they're happening on the device itself. Now what we can do is to train an AI model that predicts or estimates what is the instantaneous lateral and longitudinal angles which the cane is making, because these are the two quantities which are needed to characterize an incorrect gait with the cane and a correct kind of a gait. Right? So the data comes in, high fidelity data, it's a time series data which is coming in. It goes through a certain kind of an architecture, and this is a neural architecture which has certain details, and I can go into the details a bit later. And then it produces some kind of a sound or some kind of a feedback to the user. Sometimes it can actually say that most of the time you were accurate, but some of the times you had exaggerated kind of a tapping. That means that if you put a sensor here, it's not going to be effective. So please improve. That kind of a feedback can be given. So here you see the beginning as a prototype again to establish the concept, but after 3 years it has reached a fairly small amount, small size. Now this can be put on a cane itself. It can be put on a shorter pediatric cane, like for children you can have a smaller cane, and then it will start performing the same kind of function. So how does it look? To the trainer, the interface is something like this. There is a nominal range, the green range, in which tapping is perfect. And here it is talking about the amount of slant, amount of right-left kind of a movement or vertical movement which you are actually seeing. And as the person starts moving, you will see that the instantaneous position is then tracked. Now the trainer can be remote. Trainer can be in Delhi, the person can be far away, right? So it will transmit that to a centralized data aggregator, and then this data can be then processed appropriately. So here you see on the left hand side the actual movement of the cane. The AI module is deployed on board, and on the right hand side you're seeing what the predictions are coming out, right? Now this data, it can be summarized in text. You can look at it statistically and guide the person appropriately. For example, if you say that the slant is not correct, you can say some kind of a sound, right, to say that you actually need to reduce the cane to hold it appropriately, right? So that means in future we're going to have these AI kind of trainers which will take input from the high level instructor, who will say that okay, this child needs this kind of a training, and then the person is going to practice that with the AI for some time, and after a few hours this data gets back to the trainer, and then he or she can appropriately make a decision on board. So this is on the user side, but on the technology side, let's also look at some of the aspects which were required to make this work. There are three aspects which are important. Number one, the latency, right? So a lot of effort needs to be made in order to make neural networks work fast. So this is a transformer-based architecture, which in general is also fast, but then effort is needed to make that really go fast. And second is that this needs to be deployed on a really, really low-cost microcontroller, the ones that you are also using. Now, most of today's AI runs on graphics processing units or GPUs. The smallest one themselves, something like NVIDIA Orin, is this big, right? It's not possible for the user to carry that kind of a system. And hence we need to completely sort of change that paradigm of power-hungry large networks to small, highly quantized and power-efficient kind of neural networks. So a lot of effort, almost 1.5 years of effort, was only to make this to work on a fairly low cost and low power thing, and that also has a bearing on the kind of architecture that could be designed. Okay, so this is one example of AI-based training for mobility. Let's turn our attention to another application area, which is in education, and look at two examples in this domain. Yesterday, I was, listening to another talk from Mr. Christopher Lee, who was talking about accessible books and the work that his foundation is doing in making accessible books available everywhere. Now, what is an accessible book and what is its importance? Let's say you go to a school. The government usually mandates that there will be a person with different challenges will be accommodated in the same classroom. That means I will have my lecture notes, I will have my textbooks, and all of that information needs to be available real time, rapidly, in the format which is needed for the child who's using it. Most of the time, this is a problem for print disabilities, which is visual impairment, dyslexia, etc., etc. Now, a number of organizations do this process manually. Okay, so a book comes in, some trainer will sit, they will manually convert all the diagrams, describe all the diagrams, chunk it up so that they can go back and forth with the appropriate piece of information, and it takes almost, in the centers that we work with, it takes more than a month to actually produce a high quality book. It has to be verified, it has to be checked with the screen reading software, it has to be appropriately chunked, etc., etc. And that's a big problem. Now this means that if you look at the total number of textbooks, if this is X, the number of accessible textbooks are firstly not more than 5% of X. Further, they are so delayed that the relevance goes away. For example, if you're reading a journal, the next issue of the journal will come by the time you convert that journal into an accessible format, which is completely, it defeats the purpose of the journal in the first place, right? So both of these challenges are there. So what our center started looking at is, can you make the situation better by accelerating this through AI? So what was the use case here? The use case was to look at the most challenging parts, which is image conversion. And today's AI models have the capability to convert between images and languages because they're trained through a tokenized process that goes in between these two. It's a function that takes an image, can generate a text, and it can take a text and generate image, etc., etc. But the important part here, which was also mentioned yesterday and very common, is that not any description is a good description. There are guidelines which have been established. For example, BANA guidelines or Diagram Center in the US has established guidelines on what it means to produce a high quality annotated diagram for an accessible book. So we need that feedback also in, and hence the human part also comes in. So if you are a special educator, in our system you can actually encode some of these rules, that please follow this rule, this is an example of the rule being followed, and then the AI system is going to generate the appropriate kind of conversions. So you can take an inaccessible book, you can provide these guidelines, you can break this up, and there are various details here which I will not mention here, but there is a certain agentic kind of a framework which will produce a book appropriately. So here you're seeing the interface that the special educator will load up a diagram. The AI will start operating on it. You will also supply some of these guidelines. You can select which guideline you're working with. For example, America has a different guideline, India has a different guideline, Sweden has a different guideline. You can go between them and you start seeing the image get converted into appropriate text. Now this can go directly into a Day-3 reader, and the Day-3 reader can then pick up the accessible book. Now this means overall our finding is that one is able to accelerate this process at least by 40%. Right? Because there is still human in the loop, it needs to be done, but one is able to get to that point. Now if I say 40%, the next question should be, what is the accuracy? What is the quality of this? The quality was found to be good but not great. So AI can get you to that 80%, but that 20% is still there, and the reason for that is that the textbook also has a lot of context. So if you're reading a chapter, let us say on Kuwait history, you would have a lot of text and then some kind of a diagram will come in, and then some other things will come in, and that is a little bit challenging, which is what we found for the AI to figure out. The background text, etc., that information it misses. The second part, which is not there in today's AI, is to not give an answer. You see, if a child is in a class and you give them an exam question, the child cannot ask you to give the answer during the exam. Right? It will defeat the purpose of asking the question in the first place. So we do need AI systems in the educational context that don't emit the answer itself. They wait or they require some kind of intervention before that answer is given. Right? So ChatGPT, when you ask a question, it never says I will not answer. It just gives you the answer. Right? So a lot of these models are designed in that way, so we need to have some other guardrails as well. And this is important in the educational context to have these fine-grained controls, and this does not exist today. And the models as they are coming or evolving would need to have that capability. Again, the whole paper talks about not just the proprietary models, but also the open source models, and their performance a little bit less, but at least that opens a path towards accessibility. Now the other advantage of AI is that it can do many things together. So it can do images, it can do braille file conversion, it can do tactile supplements, and those are other areas that we've also explored. Okay, so this is about conversion of books, but conversion of books is almost like scanning a document and then interacting with it. So this is essentially operating in a constrained kind of a lab-like environment in which the scanning is happening, the AI does this thing, the special educator checks, and then we give that back to the end user. And this service is already running at our center, and we're regularly doing that with, children are going to send their books or their parents will send the books, the conversion happens, we give them back, and so on and so forth. That process has been set in motion. But there are other areas where accessibility is needed in the school in a dynamic condition. Right? So imagine doing a chemistry or a physics experiment in class. Okay? So let's say you're teaching circuits and you're teaching about conductivity or resistance. So the standard experiment for teaching resistance is to take a resistor, take wires, and change the resistance and then measure the current for a constant voltage. That's a very standard experiment that we do. Now what is the child expected to do? They're expected to first build the circuit, but they're also expected to measure the resistance. Now how do we measure the resistance? We have a meter for it, right? We have ohm meters, or we have various kinds of other meters which are there, and the person needs to go through that. Now the problem is that for a visually impaired person, the meters don't make sense because they cannot read, they cannot actually see anything on the text. So now AI can come in again, where the child can pull up a phone, or there can be one in the lab, and whatever reading is there in front of you that you can ask the AI to tell you just the reading part. So 15.159.5 or 31.8 or 0.74. So this is an electronic meter. This is another meter which is measuring weight. This is a vernier caliper. So when you have to measure a length, let's say you have some mechanical experiment, length measuring units, they are something like this, right? Obviously, if somebody embeds audio into it, it will become accessible, but you know, people don't do that for cost purposes, etc., etc. And again, AI has to then do this for us. So can I point a camera to this kind of a unit and then check for it? So we started investigating this because this problem happened in India because children with visual impairment were not allowed to do chemistry experiments, physics experiments, because they said that they cannot see the color change in the chemical and so on and so forth. They cannot do anything, so they were not asked to leave the class, and hence we started intervening at that level. So what was done in this investigation was to create a first data set of these kinds of tools or these meters in classroom environments in various schools. So this data set is available. It's about 1,300 images, which is there. And then we started looking at, can AI be appropriately, you know, engineered or fine-tuned, or you know, can it be asked to read that on the fly, right? And the results were promising, but there is some gaps that we identified. So the reading accuracies are actually high. So about 90% plus is the accuracy, which is fairly good for this kind of a system, because the remaining you can fill in, because you roughly know from the formula as well what kind of a current should be flowing, etc. So you can sort of make this out, and this is instantaneous accuracy. So if you take multiple images or you do this over time, my guess is this will actually ramp up to nearly 100%. Right? But there are certain problems on the type of data itself. For example, analog meters are very difficult to read. Digital meters are easier. Right, so this is a digital thing, and this is very similar to text as we see it on a computer. So the AI is actually trained at this, so it is very good at this. But if you have a meter of the old kind, when you have voltmeters or continuous meters or gas meters, those are very difficult to read. And hence that's where a lot of these mistakes happen, where analog readings is something that AI today can't do. So anyhow, we have to fix this problem by creating our own data set, or we need to engineer in a certain way. And in any case, today's models are very discrete. They find it difficult to, in general, deal with continuous variables or continuous quantities. So this needs more work. But at least it is promising. At least it provides some kind of a solution. The other idea is, once you can recognize the reading, you can change this to a high contrast. Let's say you don't have a visually impaired person, you have somebody who has low vision, or certain colors are not visible. You can change the contrast, you can do large font, you can do audio output, so on and so forth. So that kind of a system can finally be built. So this is another example of in the wild kind of a use case where children can be now allowed to do experiments in class. So our main demonstration has been that in a classroom context, can they do an electronic experiment without being able to see? Right? And we have some evidence for that, and it's been really rewarding to see a blind person actually use this to conduct a chemistry experiment in which the color of the dye changes, or do a physics experiment and actually say that I am making a reading of 28.4 and then writing it down and then plotting a graph and so on and so forth. So that kind of a future of inclusion is emerging. Now this takes me to the last 5 minutes of the talk, which is on frontier technologies. So we've seen something in mobility, we saw something in education. Now let's look at what kind of a future we can imagine, which may actually go also beyond visual impairment. So I saw very interesting work also happening at KCST, and I saw the demonstration as well of robotics, right? Of robots being deployed in care settings or home care settings, in particular, which have the ability to interact with humans in variety of contexts. Now what has happened over the years is that electronics and computation, the price has gone lower and lower. And today it's becoming possible through 3D printing and this kind of AI embedded technology or computation that we can have machines that we can interact with fairly at a lower cost. So gone are the days of the 1990s where robots were very expensive. They were kept in cages. In industry, they're still kept in cages, etc. And these robots are sort of leaving that environment. And as I said, AI is also becoming pervasive. We have AI on the phone, we have AI everywhere now. So all of these are going to get mixed up together. So things of the future are now becoming more and more common. For example, during COVID time in India, there were experiments of using these little robots, very similar to the ones that you have built as well, to deliver medicines and deliver sanitizers to COVID patients who you cannot physically go and do. Japan has been working in this technology for a long time. So they have a fairly large elderly population, and they've been working towards robotic agents that can actually help the elderly at home for fetching tasks, for just social integration, and you look after them. And they've been working for a large number of years, something like 30-40 years. A lot of effort has been there in geriatric population being supported by robots. And we imagine that in the future, we should be able to have robots to assist in para-nursing kind of a setups in both homes and in other places, let's say where you have people with spinal cord injuries and those who require persistent kind of care. So we'll see some kind of a new results. This is from a lab of robots being able to respond to high-level instructions. Okay, so this is a robotic arm in a lab condition, and the command that has been given is fetch the green cloth and give it to me for a wiping task. Maybe you want something to be given, and the machine is able to process that language. The audio is probably not coming here, but it listens to the language. You're able to talk to it as if you're talking to a human, and it says, okay, I find that green object here, and I'm going to bring that to you, right? So in this little demonstration, you saw all of that, high-level cognition, planning, action execution, then recognition, all of that full stack being executed. Now you can actually today also build more and more intelligent systems. So let's watch this video and then I'll talk about it, right? So a person comes in, he uses some cloth for wiping. So he uses this for wiping, right? And then he's going to go away. Now we're going to ask this machine to throw away the items that were used, right? So let's say you're helping the nurse, right? So somebody had used and you want to actually throw it away. The machine recognizes among many other of these cloths that this is the one that had to be thrown away, right? Now what is powering this? This is today's AI. This is today's agentic AI, which is multimodal, which is able to do this kind of a reasoning, and this one is able to do, right? So in future you can imagine that, let's say a person has a fall. So you say pick up the person who had a fall, or something fell from my hand. You could actually say, robot, pick that up and bring that to me. And we are seeing evidences of that because tomorrow products are in today's labs, right? So you will see this kind of a technology mature. On the other side, if robots have to enter our houses, we need to have a much more natural interaction with them. So let's see the interaction on the left, and then we'll see what underlying technology is happening, right?
All the edible items from here to there.
Okay, so what is being said here is put all the edible items from here to there and then remove something. So it's a very natural interaction. This is not a programmer who's programming the robot. A natural gesture. These are called co-verbal gestures, where there is language and there is also this physical interaction. So the robot is able to understand that high-level gesture. Like put all these items here from here to there, right? And this is very powerful. Why? Because, and then the robot will perform this task. So it is picking up the edible items. So we have this little fruit. Actually, this is a plastic fruit. So you pick this up and it will now pick up the carrot, pick up the banana, and so on and so forth. It will leave out all the metallic objects, right? So that high-level cognition happened, right? These are the objects, then it applied common sense knowledge, so on and so forth, and this sort of opens its doors. So what does this mean? This means that human-machine interaction is going to change. Let's say a wheelchair-bound person can say, robot, bring me this item, right? Or somebody who's taking care might say, clear away the urine pot. So bring this medicine or throw away these kinds of things. So those kinds of gateways are opening up, right? So the robot will keep performing this task, and it can be 5 to 10 steps, so on and so forth. On the right-hand side, you see the view from the robot itself. So this is a in-hand camera which is observing the scene on which this kind of a reasoning is happening. There are more technology pieces, there's mapping and other things happening, but this kind of a thing is emerging. Okay. Okay. So the final part here, I will say that when we talk about robotics, people say that it's going to take away our jobs as well, right? And that's a question that always comes to our mind. And we've been very conscious about this technology as well, and we slightly think of it differently, or at least we're trying to think of it differently. We imagine these robots to be like our teammates, right? That's why the title of the talk was AI plus human. If you leave the human out, it's not going to do what we really want it to do. And the point here is that robots also need humans quite a lot, okay? So the new kinds of jobs that are emerging are people who will train robots. So what you'll see here is a system in which the human has demonstrated the machine to do a particular clearing task. Okay, so you see a clearing task again. These are medical items. Okay, so it's like a medical throwing kind of a task, right, which is being done. And just see the motions, and then I'll tell you why this motion is happening. Okay, so you'll see a picking up, right? So the robot goes there, picks it up, and then throws it away, or it'll do some packing, and now it'll pick up the handle and put it there, right? Does this look human-like? Does this look very human-like? It does. It does. It looks less mechanical than the experiments before. And the reason for that is before they started, the student has trained this machine. So the student came, the student showed how this is to be demonstrated, and then we're using state-of-the-art imitation learning and reinforcement learning methods to do that, right? So these are human-trained robots, and that's the important part. That's why we're getting this kind of a graceful kind of movement which is there. And that's in some sense the future which is emerging. That there'll be, just as there were annotators for classical AI, for robots they are going to be behavior model trainers. There might actually be new jobs being created as well who are going to train these machines, and then when you go away it will do that task for times to sort of come, right? So these are sort of first demonstrations for that, and you sort of see this sort of emerging, right? And to conclude, we've reached the end of what I wanted to talk about was AI clearly is a technology which is having transformational impact. But like any tool, like computing, to harness these technologies to make their lives better. With that, I will end. Thank you so much for your attention.
Thank you, Professor, for your impactful presentation. So, any questions?
Thank you, Professor Rohan, for this interesting presentation. This is Engineer Mustafa from the Electronics and Communications Engineering Department at KCST. Actually, I have two questions. The first one regarding the Introspect instrument. Can it be deployed in critical labs and hazardous labs when they need no delayed answers? Can we implement this instrument?
I think the latency is about seconds. It's not milliseconds. So if the the experiment does not require that level of accuracy, and most of the time in schools it does not. So in that setting it does work, but I think if you push this a little bit further, I think this is a very interesting point. That can we make it even more precise? For example, one of the experiments in chemistry is when the acid and the base has to neutralize, the color changes exactly at that point. So if you miss that or the AI misses that, then the experiment will not go through.
Exactly.
So I think there is some tolerance I can find. I think it's in seconds, but I think a little bit more needs to be done to make it really precise, to a very, very precise level. But at least it works to a certain extent.
Yeah. And regarding the robot that is picking up the stuff, I see in the video that you displayed that it's trained by the user by gestures and voice commands. Can we get rid of the gestures for people with disabilities?
We can.
Yeah, so it can depend only on the voice command.
Yes. So what do the gestures do? The gestures are actually compressing a large kind of a plan, which is more difficult to describe in language. Pick this up, put it there. Pick this up, put it there. Pick this up, put it there. Instead of that, if you just say pick all of these things up, it becomes simpler. So it was for that objective, but one can, also rely on not using gestures clearly. Yes.
Thank you so much.
And maybe the other way around. If a person cannot speak, then only gestures is also possible. Sir.
Professor, it's not a question, it's a comment. Just to comment, I had the honor of visiting your lab in New Delhi, and just to say that fascinating things that you have shown is a small subset of what we have seen there. So these are life-changing projects, actually. And but just regarding that chemical experiment you mentioned, we have witnessed during the conference a workshop on what's called scent of color, and they used a device that helps recognizing the color. So you can point it on color and it tells the color info. So this can be combined to complete the experiment completely.
Yes.
But thank you very much for being with us and honoring with this experiment.
Thank you so much.
Thank you, Professor. So now a token of appreciation. Okay, another. Yeah, just a quick question. It was an honor to host Professor Balakrishnan last year, an impressive talk, and yours is the same. So, did you think of this as like a solution? We know about intelligent transportation systems where the cars talk to cars, cars talk to infrastructure, the V2X. What about these sticks? It becomes like a navigator.
Okay.
It communicates to, to the infrastructure, and I can talk to the stick, please take me to the nearest shop, or so can it be implemented in this scenario? Thank you.
Yes, absolutely. So I think you mentioned Professor Balakrishnan. He's been my teacher. I was a student as an undergraduate at the same institution, so I have attended his classes. And he stays connected even after retiring from the institute, and is a lot of inspiration for us. Now to the second part, I think what you're saying is extremely important and something that we need to think about. Now the reason why connectivity is needed is because we can have one color, we can have one of our system, we can have one stick, and we can keep doing that. But how do they come together for the person? The person wants to go through college or school on their own. They're not interested in, I want this technology, I want this technology, I want this thing. So it's got to be integrated. It's really got to be integrated. Let's say in a school environment, can it guide the person to actually go to the classroom? Then automatically can you switch to translation? Then automatically can you change to some other aspects? That's the seamlessness which is needed. And I think that's where the connectivity is definitely going to be there. So one of the objectives at least we are thinking about, and I would encourage others to also think about, is that can we create a small classroom in our university to say this is the future of an accessible classroom, which is networked, which has books coming, which has hearing, etc., etc. And I think that's where connectivity is going to be absolutely critical. So I think what you're saying is really something that we should work towards in the future.
Any question? No question?
Thank you, Professor Rohan, for the amazing presentation. I'm just wondering, obviously the hand robot, uses a large language model. Which one does it use for the time being in that experiment?
Right, so as researchers, we decided that we are going to work with 3 categories of models. Number one, the proprietary models, because they are the state of the art, they're industry backed, but they are closed source. Then we work with, so those are GPTs and those perplexity kind of models. Then we work with large models which are accessible through a server, and we set up a server in our lab as well, which have models like Quen and many of the other models which we can have access to for training. And the third set of models are those that can be deployed in IoT kind of setups. Those are the small language models, or those that we can fine tune as well. So here you're seeing is a synergy between all 3. For example, the text to speech is actually a very small model, which can actually be deployed in a very fairly small, this size kind of a unit. Whereas a reasoning model, which is required for, let's say, the image part, is something which is a bit bigger, right? Now this allows us to I don't have an answer for you, because obviously the best performing models are not accessible kind of thing, but at least provides a path where you can start understanding the trade-offs between them, and where we can fine tune, where we can modify them with that thing. So we have sort of results for that. The open source models do lag behind by at least 10 to 20% from the state of the art models, but then it's for us to now work with our students to improve that performance overall. Yeah.
Another question in terms of, you showed us the 2 scenarios where one, the robot was not trained by a human in terms of how it should move, and the other one in which it was trained by the human in terms of to look more like a human moving. In terms of power trade-off, did the first solution consider the shortest path maybe, or the power constraints?
I think that's correct, right? So the shortest paths are, we are assuming that the human is demonstrating in some sense the geodesics. The shortest path is there in the imitation. So suboptimal demonstrations may actually make the path longer for the robot to do. But what the human does is that they are very good at not failing at the task. We might not optimize for time, but we'll optimize for picking it well. Whereas on the robotic side, what happens, you can be very fast, but most of the time you may just miss the whole thing. You miss the grasping part. So that's why the humans are more careful. They might spend 10% more time, but they'll do the part more robustly, and that's what we needed for this application. But I think it's a very valid observation.
So thank you, Professor.
Thank you.
Thank you so much. Please, a token of appreciation will be gifted for our or to our guest by Professor Khalid Al-Baqain. So now we move to our next item, which is the discussion panel, titled Digital Accessibility, Where Does Kuwait Stand? Let me invite the moderator, Dr. Ziad Bouda from the Kuwait College of Science and Technology to the stage, please. If you don't have class, please stay. So, okay. So, welcome everyone. Welcome to our guests for the conference, and we are happy here to start a very interesting panel. The panel touches on a very important topic. It's digital accessibility. So, when it comes to digital accessibility, it's a very crucial topic because, you know, what's happening around the world now. There is a big talk about the digital transformation. There is digital transformation and the new solutions, either in terms of AI, agentic AI, and all of these solutions that support us. Now the question is, when we talk about digital transformation, is digital transformation considering everyone? Is it something that is inclusive? Is it considering that there are people in a smaller concept? We call this, the people with disability is a category, but in general we talk about people of special needs. I mean, I can be someone who needs glass to read. I'm a special need person. So the scope of covered by special need is more than the scope of people of disability. We are fortunate today to have a young panel, young in age, 100% Kuwaiti panelists that will contribute to this discussion and will bring the discussion from three different perspectives. Because when we talk about, you know, the digital accessibility, and we need to bring it from the technology side, okay, which is very important, from the policy side, even more important than technology, and the third part is the user experience. So are we providing solutions that it can be used by any user? I mean, he cannot use hands. How can he do things? We saw very good, you know, keynotes about solutions for blind people, for deaf people. So that's what mainly our, panel will touch. And I invite each one of you, because, you know, sometimes you have some food, preferences. You go to a restaurant, you don't find, that's a special need. If you don't find your choice of food, you become upset. So that's exactly, I mean, in all aspects of life, accessibility is required. And I'm honored today to invite the panelists shortly, but I will give you an idea about how the panel will take place. So it's non-conventional. We'll start with presentation slides by our panelists. Then we'll do a first round of questions, and then we'll also involve the audience, so please prepare your questions. So let me invite Engineer Saud Al-Akili, who's the Director, Customer Support IT from STC. Please join in stage. Engineer Naif Al-Awadi from Kuwait Information Technology Society. Engineer Al-Awadi has been a partner with us for many conferences, so thank you for the support also. And STC, worth mentioning, they are also sponsoring, a platinum sponsor for our event. Engineer Amna Safar, a very big role played by the PADA. And Engineer Muhammad Ashkanani from W3C, GCC chapter. Please join in stage. So now we'll start with the presentation, and the presentation basically will give you more an idea. It will serve as an introduction to our panelists, but also it will give you the contribution, insight of the contribution of each of these parties to the matter or the subject, the important subject of digital accessibility. So please, Engineer Saud, if you can start.
Okay, thank you.
You can either join here and then one by one present.
Thank you, Dr. Ziad. I think the others stand here. Thank you, everyone. Good morning, everyone, and thank you for having me today with you. So basically, when we talk about digital accessibility, of course, this is a very important topic to talk about. We are witnessing a very rapid technological evolution, and the acceleration of the technology is there. So I think today we should have equal opportunities to use and enjoy this digital transformation and the AI. So when we talk about the industries and the perspectives of industries, so we should be responsible, and we should have all equal opportunity. So the ethical duties should be, we should ensure also that with the disabilities includes in all participate with fully in terms of digital experience. This will also give a repetition for the industries to show that they care about the diversity and inclusion, which earns trust and loyalty, which also would reflect a brand repetition, and at the same time this is a business advantage, which will also give and reach more customers, and this will also open a new market, and of course will give a revenue and growth of the organization. When we talk about user experience, so this is basically how the feelings and the interaction with the digital products, and we should make it as simple in order for everyone to easy, and how to use them in a very easy and very easy manner. The design, when it comes to the user experience, always the design matters, because we should take into consideration the different abilities, whether they have problem in vision, hearing, and movement, and the way they think. Benefits, of course, are accessible, gives users more control, keeps them engaged as well, to build strong customer relationship. So why the accessibility is important in STC? Of course, as we said, that it gives an overall user experience, expand STC services to reach more customers, build the reputation and the brand of the organization, and of course, we should support Kuwait Vision 2035 for the digital transformation and equity. Thank you.
So I'll invite Engineer Naif Lawadi.
So Kuwait Information Technology Society is a non-profit organization supervised by the government. Actually, it's all care about the professional society and professionals in the field of information technology. So our role is significant and important in the journey where we can apply and follow up the implementation and or maybe the fostering the upgrade of the framework of digital accessibility. So we have here three main angles: deriving the awareness, training, and establishment the digital accessibility. So for driving the awareness, we conduct society awareness program. It is very important to start with a program for the awareness. Organized program will deliver different goals and key actions, collaborate with ministries and universities in the same manner. Those are the main action for driving the awareness. So the expected outcomes are broader recognition of the stakeholders, those who care about the digital accessibility framework will be recognized more. The framework will be distributed much, increasing the understanding level of digital accessibility framework. This is the other expected outcomes. For the Digital Accessibility Association, this is an association already established under KITS. There will be an engage with the professionals and support policy alignments, of course, from the other side, and the expected outcomes establishing accessibility leadership through a sustainable government models where we have the goals of the association itself. For the training, of course, there will be a dedicated training for developer designers for the content creation that follows for the web content accessibility guidelines. Workshops, of course, certification programs, all within the support from W3C program courses. Expected outcome, build a qualified society workforce. So I will now shift the talk to Engineer Amna.
Good morning, everyone. Today we will start with the digital accessibility framework.
Covering some of them.
Okay. Actually, the story starts with digital accessibility in 2018 when PADA signed an agreement with the United Nations and KISR for achieving Kuwait 2035 vision towards persons with disability. Part of that agreement was specialized in digital accessibility, so we published the Kuwait National Framework for Digital Accessibility 2018. But there were there were many problems. One of these problems, when COVID-19 happened in 2020, all government ministries went down, okay, and most of the important services went into online services. But we had a problem that people with disabilities were not able to use these services, these online services, because they were not accessible to them. We had many challenges at that time. Some of these challenges are limited awareness about digital accessibility, constrained collaborations with the specialists with the digital accessibility, and there were no communities that understand the digital accessibility. What we did to overcome these challenges are some of the steps that we started to do in 2025. PADA signed an agreement with W3C GCC chapter to update the Kuwait National Framework for Digital Accessibility to the latest WCAG version. And we started already to build Kuwait Digital Accessibility Framework Committee to foster the digital accessibility framework and start updating this Kuwait National Framework for Digital Accessibility, and spread the awareness through the community and make the people with disability and special needs able to use all the services provided by the government ministries. Thank
you. Good morning, everyone. All right. What I would like to talk about is where Kuwait stands today. Where is the digital accessibility of Kuwait? The good thing is the foundation is there. Kuwait already established the Kuwait Digital Accessibility Framework. And when I look for the government sectors, now Kuwait already shifted to using online applications, e-government services. But when we look for digital accessibility of Kuwait, we still have limitations. We're trying to see the government websites, we're trying to see application of private sectors and non-private sectors. We can see there is some part of accessibilities, and the law of Kuwait as well is supporting the digital accessibility, which is great. But all the time we ask ourselves, what is our current challenge in Kuwait? Kuwait digital accessibility is still using WCAG 2.0. This is one of the major problems that we face. The other problems of the communities, there is limited training and awareness, where we need to focus on education. I really want to give a good example about digital accessibility. Why I shift and specialize in digital accessibility. One of the reasons is education. When I was in Australia, I did my study. Australian community very strong with the digital accessibilities, where I decide to study and specialize in digital accessibilities. So education is playing a big role in that. We found the other challenge, there is no any KPI or national monitoring or index to reference where we are. And then when we see all the websites across all the departments, we see that it's not accessible. That is another challenge. Accessibility not integrated in the development process. I found that because they use accessibility as an option, not as a requirement. International best practice that we can use. Most of the global now shifting to WCAG 2.2 AA. European Union implementing already the audits and accessibility statement on their websites, where we use in Kuwait still the accessibility statement is not there and the audit is not in the right way. Where Kuwait is going, this is the most important part for now. Kuwait is going to update the digital accessibility framework with BADA to use WCAG 2.2 and develop the national accessibility KPI and monitoring, which is the most important part to see where we are. And then training and certification program is going to play a big role to make Kuwait accessible by training the staffs and user and communities. Finally, which is the most important part, integrating the digital accessibility in procurement designs and development cycles, because without that we cannot achieve the digital and vision of Kuwait. Thank you.
So we'll proceed with the panel with an important note. The note is about connectivity. So connectivity is very important. We know that according to the ITU, around 3 billion people are not connected now to the internet. It's a big number. So in order to have the basis for accessibility is connectivity. So you cannot like drive cars if you don't have roads. So I'll start with Engineer Lakili. What is like these telecom providers, STC and others, providing, contributing to the digital accessibility?
Okay, thank you, because yeah, that's a very nice question. So yes, as you said, so basically the most important is connectivity. So as STC, we do enable the connectivity throughout Kuwait. We do have a various of digital channels that connects everyone digitally, whether through our websites and digital channels, and this we all support the accessibility.
Very good. Yeah. So, Engineer Ashkanani, you touched. I mean, you want like basically the story of the panel is to show where we stand and also to recognize the gaps. So, what do you think is and the question is to everyone. What do you think are the main gaps? Let's start with the negative parts in order to end positive on a positive note. So what do you think is missing?
So far, what I have seen is the awareness and the concept and the foundation of digital accessibility is not there. Whenever we visit any community in Kuwait, that we can see that accessibility or the meaning of digital accessibility has different concept. Someone, they think accessibility that accessible of the website. The other people think of the security perspective, but the terminology in a way that to understand that people's disability to access the website is not exist in the community or most of the organization in the community. That is the major part that I can say.
Very good. Engineer Naif, do you want to address?
Of course, in addition to what the challenges that he mentions, another part is the society and community and the awareness level that everyone know about the accessibility until today, and even there is an establishment of the digital accessibility framework back in 2018. Still, there are many people, even in the tech, other with the society or professional, they don't know about such a framework. Exactly. So this is a part or maybe a channel from our side as an NGO to deliver the level of awareness and to enhance it, because you cannot engage with a full governmental program without engaging the community and society.
Yeah, it's really, really interesting point. Recently, we've been, involved in a project with some partners from Kuwait to evaluate the websites of universities in terms of accessibility, and we found a big gap. I mean, even for students, we don't talk even as people with disability, but even for example, in a website, a blind person, the photo should have text that describes what's going on the back. So it's very important to have such accessibility, and this is what we call like the accessibility by design. It needs to be built from day one or day zero. We don't like build a solution and then let's add these add-ons. It doesn't work like that. So certainly these gaps will bring opportunity for NGOs. So how do you think these NGOs, can take advantage of this in order to contribute to an inclusive, digital environment?
Well, as I mentioned, the NGOs will foster, will support. It cannot work by itself, and the whole program cannot run by itself. It's all together. It's a one channel. It's one angle, part of the whole program to support and to execute to a broader level.
Excellent. Yeah, I was reading about the topic and I see, like, just to understand in terms of policy, we have like الأمانة العامة للمجلس الأعلى للتخطيط والتنمية, which is the general, like the Supreme Council for Planning and Development. Also in the same context, we received some comments that some people of disability may have access, not only the digital access, but access either even to buildings. So now I think the new policy in Kuwait in terms of design, they need to take that into consideration. So, did you take into consideration this when, for example, PAD, I think you receive a lot of feedback regarding the shortcomings, and are there any serious efforts to get this resolved?
Yeah, actually, in 2018, part of the agreement signed with PADA, part of it was related to the accessibility of the buildings as well, not only the digital accessibility. Okay, so this part of the buildings, it's active now. Engineers from PADA go out and check the buildings of the malls, the general buildings of the ministries, and they give their opinion, the technical professional opinion, we can say. Okay, they give their official opinion about the buildings. There should be overcoming to the some of the specific guidelines of the buildings, and they are activating it actually right now.
Very good. Now, in terms of implementing the accessibility framework, I will, just to give you an idea, the national framework for Kuwait digital accessibility was established in 2018, but the good thing, it's being revised. So 2025 we have another. So Engineer Ashkanani, now you have an agreement with PADA to make sure that this is implemented. So what is the progress on that, and where is it going with the vision of 2035?
You mean 2035?
2035.
Yeah, 2035. Yeah. All right. The good part is the digital accessibility framework will be released by January 2026, and is going to be applied to the all government and private sectors. But again, the framework itself will not help, because what we need in accessibility is a commitment from all the government, education sectors, private sectors, because accessibility is not a task, it's a journey, and that journey needs a commitment. Without the commitment from the higher top management of the government sectors and private sectors, we cannot shift Kuwait to be accessible and usable application and software. The framework exists and is well established, and the revised one that will be released by January 2026 will be applied. The latest technologies will be covered, the guideline, international guideline, and European nation recruitment guideline as well. But again, we need a lot of things to be done. One of the parts is a training, especially how to implement it, and that will be happened by next year. And again, it's going to be a journey, and that journey will take Kuwait to the level that we can apply the national transition strategy to achieve the goal of accessibility.
Yeah, excellent. Yeah, really, I think it's already recorded on YouTube. We have this event live streamed and also recorded. Yesterday, you can access to yesterday presentation by Dr. Christopher Lee. Very interesting about the accessibility. There is something called DARE, which is Digital Accessibility Rights Education. So when we hear the word education, I think that's one key aspect. Before I go to the education side, we remember what happened in COVID. You touched on this. Even big countries, talk about the UK, for example, they discovered there is a big, digital divide. I mean, even designing, solutions for people with disability is not about the daily life. What happens in case of an emergency? Like, let's say something happened, the sirens go off here, and or the alarm, the fire alarm, and then the exit. Do the people with disability have the same chance to exit as we have? So there is a lot of aspects. But I just come back to the point of education. Education is very important, and in the broader scope, we talk about raising the awareness. So I think STC, other than providing connectivity, which is important, you lead a lot of activities about raising the awareness about digital accessibility. If you can touch on that.
Absolutely. Actually, yes, we do lots of campaigns and awareness campaigns to touch any things that touches the accessibility. We do have people where they give the awareness to different various of people, whether in the educational sector or let's say ministry sector as well.
Yeah, I think also there is a very big importance of the media. How can the media play the education, the universities? I think it's really good what you are doing. Any one of you want to touch on the awareness? Probably PADA launches campaigns and.
Yes, actually we established like a committee, we can say, committee to build up the Kuwait National Framework, and this committee will be committed to continue updating the Kuwait National Framework, because it's not about, as my colleague said, Engineer Mohammed, it's not about publishing the framework. It's about continuous work and commitment. And we started already the committee, and inshallah we will be having regular meetings to discuss all the details regarding the document itself, documentation for the framework, and for applying this framework on all ministries, websites and applications.
Very good. Now I think we have 5 more minutes. We can get one question from the audience. and then we'll come with the concluding discussion. So just to keep it short and up to the point, Engineer Mustafa is not allowed to ask. Yes, Dr. Mario, please.
Okay. Good morning. Thank you very much for the excellent panel. This is a question I really touched me because when I start in Portugal, we did a project to make accessible a laptop for every student and every teacher in 3 years. It was like 1.7 million, and we did it from the state, the telecom companies, and other partners, because, for example, the textbooks, unfortunately, the textbooks publishers, they were involved and they create platforms. Then, I don't go to tell you the story, but the point is, I think the point you raise, and I would like to hear maybe the society and the STC representatives here, or maybe someone else. If you have any idea about if everybody have access to technology and connectivity in good quality in Kuwait, or is there any programs for access? Because I think if we can only achieve complete accessibility, including for special needs, if there is a critical mass of usage. Otherwise, it's difficult. For example, just to conclude, one of the questions we try is the textbooks were completely digital, but only because we assure the publishers, then everybody will have, they have the capacity to invest in the content, and including special needs. Because when we create the critical mass, then everybody, then the numbers rise, and the possibility of investing in better quality and to cover all the needs is possible. Then my question is there here an assessment, and is here sure then everybody have access to a good internet access and a device which allow them to access? Thank you. Sorry for the long question.
So thank you, our panelists, so much for the reach and insightful discussion.
We still take 5 more minutes to just
Okay.
final thoughts. Yeah.
Okay, thank you for your question. Actually, yes, I think even our colleague here have touched that we are still haven't reached the, let's say, with 100%, we're still having some of the, let's say, we are still raising the awareness for everyone. But when it comes to technology and digital transformation, we are trying to make everything digital, as I have mentioned before. So, answer to your question, we do have the access when it comes to this, accessibility. However, we are still getting improved, or doing this in the progress in order to ensure that everyone with the different abilities have the same access everywhere, basically. Yes.
Okay, I think we have Professor Jimny one more question, and then we go through the closing.
Thank you very much. I would like to thank all the panelists for this very important and rich discussion and panel. I would like to come back to the accessibility of the web content accessibility. I think this point should be viewed as a strategic point, and it should be included in the national strategies. I think before several years, and especially when the United Convention in 2007, 2008, many countries tried to include and to make some policies to make or to require that the websites, and in particular the websites of the national institutions and ministry, should be related to the web content accessibility guidelines. And the W3C already has these guidelines, but the problem is a little bit difficult, because when we try to respect these guidelines, it needs a specific training of webmasters. And this is, for sure, it needs a national effort, because these guidelines, that we call it the WCAG, the name is Web Content Accessibility Guidelines of W3C. It's a set of rules. So Dr. Ziad mentioned, for example, for every image, it should be a metadata. The metadata contains the description of the image. This is, for example, for the blind. When the screen reader reads the text, and when the screen reader arrives to the image, it cannot read the image. So it reads the metadata. The metadata that the webmaster programmed. And there is a lot of similar. And the set of these rules is divided in three subsets. When the webmaster respects the first subset, it's the label E, or bronze. And we find something, W3C conformity, and we find E, or double E, or 3E. Double E is the silver, and 3E is the gold. It depends on the conformity and the respect of the whole role of this set of guidelines. But as I mentioned, this should be treated as a national strategy, because it's a right for people with disabilities to access to the content, and especially for the services, because people now use the websites and use the application to to apply for any service, for any administrative service, and we should not exclude people with disability. And the exclusion when the website or the service is accessible. Thank you very much.
Thank you, Professor. Thank you, our panelists, for
A final closing.
the rich discussion.
Just,
We are too late.
If you allow me one very quick comment about Kuwait, because I want to put this. First of all, I was showing my colleagues here. Kuwait has a lot of features that should make the task easier than other countries. I lived in the UK, where we had many issues about disconnected areas, digital divide, lack of connectivity. STC, I am with STC on my mobile, and I just shown them we have hit the 1 gigabit per second speed, which is available in most parts of Kuwait. Kuwait, there are no disconnected areas. Basically, the digital connectivity reaching everywhere. So what needs to be done is what you mentioned started, is to make sure there is a will and a strong governance to ensure that websites, other softer obstacles are addressed. So the base is there, and Kuwait would start at much higher starting point than many other countries in the world. It's just a problem that the policy was not there. There was no framework for that. Any organization, including us when we started, that was not part of the requirements. So now we are going back to set these requirements, and hopefully we will achieve much faster than any other country. Thank you.
Thank you, Professor. Now let me invite Professor to the stage. Professor Khalid.
If you don't mind, just 30 seconds to thank our panelists. We are good on time.
Okay.
Yeah, thank you so much. So I want to thank our panelists, but again, a lot of panels take place and we listen to many discussions. That's not the goal of this panel. This panel, we invite each one of us. I think you remember the times where, for example, if I mention some people of color were not allowed in some places. The discrimination, we are over that. Now, if we are putting limitation on people of disability, I think we are back to the same. So I think each one of us should be thinking about this as a serious matter. It's not really a matter of providing access through a building. It's really a serious issue. I do really thank Engineer Mohammed Ashkanani for his great involvement through the W3C and Engineer Amna Safar from PADA and all the efforts they are doing. I think we are getting there. We started 2018, but we'll certainly get to our goals. Engineer Naif Al-Awadi from KITS, thank you for your continuous involvement in our conferences, and thank you for keeping us connected. Without you, we cannot even make phone calls. So thank you so much for our panelists. Apologize for taking it longer, and apologize for not allowing Engineer Mustafa asking questions, because his question needs another panel. So thank you so much, and we appreciate your help. Thank you. Let's go to 15 minutes coffee break, and we'll be back. Okay? Thank you. Please come back at 11. We'll resume the session at 11. We have a very important, information session from the Fire Force Department about the effort they do for people with disability. So please be here. The big initiative. So we want you to be back, please, at 11. Please come back to the same room at 11. Thank you so much.
hear us?
Yes, I'm here. Dr. Yes.
يلا مشكور دكتور محمد. Let's see if we have any questions. لأنه رشدي, you said someone like the LLM. Do you have any question? So you are using LLM in the solution. How large
Yes,
is
of course.
that language model?
Yes, Dr. Yes. Thank you for the second chance for presenting my paper. Donc, here, this paper provides how we improve the intelligent tutoring system by adding large language models such as AI chatbots. In fact, Dr. Ziad, you hear me?
Yeah, I hear you very well. Thank you. Go on, please.
Okay. Donc, in fact, the traditional ITS platforms are very good at giving personalized learning, at giving students step by step. But they are hard and slow to build because experts need to create all the lessons and feedback manually. Here, donc, the larger language model can help by generating explanation, answering questions, and adapting learners, but sometimes give wrong, confusing answers. So the goal of this paper is to combine the strength of both systems, the safety of and the structure of ITS, with the flexibility of large language models.
Excellent. Yeah. Thank you so much, Dr. Khnesi, for the details. I think it's good also to convey the message to Mr. Rida Abab. Tell him thank you and we hope probably in the future conference to have you in person.
Inshallah.
Okay, assalamu alaikum. And now you are done.
Okay.
Just we'll continue communication by email, okay?
Thank you so much, Dr. Ziad.
Thank you, I appreciate it. Thank you. Harisa, your floor is yours. If there is a mistake, you take responsibility.
Don't open Harita because there will be the names of the hour, so we don't want to display them. Or you should just remove this one if you want.
I will copy and paste it here. After this, Adil will come and open it.
Okay. Just convey the message to him.
Okay.
Thank you.
The video is already play. They have the link for the video.
Yes, already. This is not video.
Okay. Are you done with the presentation?
Already linked.
Yes. And that one, the closing ceremony. So.
But I will show to Adil.
Okay.
1 second.
Give me a second. I will use something in.
Don't remove this, okay? Link copy.
عادل مش استعمل الكرسور اللي هو بالواحد اللي يحط له لوجيتك اوبشنز. هذا ما فيه حتى مشكلة. No need to sign in, just
download.
شلون يشتغل؟ الليزر هولد ولا هولد؟ فاين يكبر منه يكبر ومنه يعطي صوت لايت.
صارت 11. اوكي ابدا.
الصف الاول من بعد لما يجي البرزنتيشن تقدموا عنده يعني على اللينك هذا بيحل يفتح الفيديو هو يطلع.
So now I am pleased to welcome Lieutenant Colonel Hamad Al-Mirshad from the General Fire Force Public Relations Department. The session is titled General Fire Force Initiatives for Individuals with Disabilities. Please join me in welcoming Lieutenant Colonel Hamad Al-Mirshad on stage.
صباحكم الله بالخير. بداية نرحب فيكم وشاكرين لكم استضافتنا اليوم معاكم. احنا من اجل الحماية المدنية نبي نسأل نفسنا اول شيء سؤال: هل احنا في بيئة آمنة وسليمة او غير آمنة وسليمة سواء في العمل او في المنزل؟ قبل اسبوع تقريبا شاركنا في اليوم العالمي لذوي الاحتياجات الخاصة، فاهتمينا من هذا المنطلق ان اليوم كون انهم اعضاء مهمين معنا في هذا المجتمع، هناك اشتراطات امن وسلامة يجب ان تكون سواء في العمل او في المنزل. بداية احنا نبي نتكلم باختصار مفيد عن دورنا احنا كقوة اطفاء عام. هو اول شيء شعارنا هو قسمنا حماية الارواح والممتلكات. ارواحكم وممتلكاتكم مسبقة علينا احنا كرجال قوة اطفاء عام موجودين معاكم، ولكن هل يختصر دور القوة الاطفاء في فقط اطفاء الحرائق واخماد وانقاذ الارواح؟ هذا الامر عفوا هذا الامر نبي نعرف اجابته. هل القوة موجودة في الدولة فقط تطفي الحريقة وتنقذ الارواح؟ احنا عندنا ادوار موسعة. نتكلم بداية من اشتعال الحريق وكون خروج المركز الى المكافحة الى ما بعد اخماد هذا الحريق وكيفية التصرف معه. عندنا قطاع الوقاية هو الحماية المدنية الأول في اشتراطات الأمن والسلامة. اليوم احنا لازم نسأل نفسنا السؤال: في المنزل ممكن بعضكم أو أحد عنده شخص مقعد، شخص كبير سن، شخص على ويلشير، شخص ذوي إعاقة، شخص شلون نتصرف معاه؟ شلون طريقة التعامل معاه؟ في له آلية. أيضا حرصنا اليوم في محاضراتنا وندواتنا ومعارضنا ننوه على أخواننا المواطنين والمقيمين في تسجيل هؤلاء في ويب سايت القوة. راح نعرض لكم اياه بعد شوي ان شاء الله. دورنا ومهامنا هو انقاذ الحريق والبحر والامطار، وراح نشوف فيديو توضيحي عن مسببات الحريق اللي تحصل واللي ممكن تدور، ومن بداية استلامنا البلاغ من ابسط حادث الى اعلى حادث. راح نشوف من خلال هذا الفيديو وكيفية التصرف مع هذا الحادث والحوادث اللي ممكن تقع تم رصدها من قبل كاميرات المنشآت نفسها سواء المنزلية أو الحكومية. من بداية استلامنا البلاغ إلى خروجنا إلى الحادث. هذا من استلامنا البلاغ إلى ما نخلص من البلاغ. هني بداية نبي نتكلم عن دور الطفل وعبث الأطفال داخل المنزل. هذا الطفل داخل المنزل أشعل ولاعة في خيمة سريعة اشتعال وانحاش، رد ثاني مرة يبي يشيك الأمر ورد انحاش. هذا الطفل داخل منشأة اللي هي جمعية تعاونية، أحد من كثر ما تعبث شب المكان وانحاش. هذا من المخاطر اللي ممكن تواجه الأسرة في المنزل أو في برا المكان. هنا أيضا أحد العاملين قاعد يدخل في مكان جاف، في مكان قابل للاشتعال، تطقم سيجارة على المكان هذا. بعد تقريبا 20 دقيقة يشتعل المكان، ومكان في اشتراطات أمن السلامة داخل المكان. عامل الحين في أحد الجراجات قاعد يلحم، ما كان منتبه باشتراطات أمن السلامة. اللي نبهه زميله اللي وراه، يعني حتى ما كان عنده علم، كان ممكن يؤدي إلى كارثة كبيرة في هذا الأمر إذا ما كان في اشتراطات أمن السلامة داخل المكان. الالتماس الكهربائي والحمل اللي حصل ممكن بسبب رداءة جودة المنتجات الكهربائية تؤدي إلى اشتعال كاملا إذا ما كان المنتج عالي جودة أو ما كان في سيفتي في المكان. أيضا هنا شفنا بسبب رداءة جودة المنتج الكهربائي شرار طاح على المكان وأشعل المكان كاملا. هني الأحمال الزائدة وخطورة الشواحن، هذا لابتوب محطوط ولكن من ضغط الحمل الزائد أدى إلى انفجار المكان. تسرب الغاز من المسببات الرئيسية اللي أيضا داخل المنزل أو العمل إذا ما كان في اشتراطات أمن وسلامة، وهذا تسرب آخر ممكن يحصل من خلال الأهمال اللي حصل في المنشأة بحد ذاتها. أيضا هني أحد العمال بسبة الأهمال وقاعد يغسل الحوش أو الجراج في مواد سريعة اشتعال، وعامل آخر قاعد يلحم، شرارة واحدة طاحت على الأرض أدت إلى انفجار المخزن أو اشتعاله كاملا، وهي لحظة مو أكثر. هذا يؤدي إلى الكارثة الكبيرة اللي ممكن تحصل في المجتمع. اليوم الأمور ممكن تكون أمام عيننا، بس احنا ما نراها بالمنظور اللي يكون فيه وقاية. اليوم لازم تكون في شرطات أمن وقائية داخل المكان. أنا لازم أعرف شلون أتصرف. يعني ممكن مثلا قاعد بينه وبين نفسه وسوى سيرش على اشتراطات الأمن والسلامة داخل المنشأة داخل المنزل. خلينا نقول احنا دائما نقول منطلق المجتمع من المنزل. منو فيك مثلا عنده مطفأة حريق في البيت، بطانية حريق، كاشف الدخان، هذه كلها اشتراطات أمن وسلامة. طيب اليوم احنا خلينا نتوجه حق الهدف الرئيسي اللي احنا جايين له اليوم في هذا الملتقى، اللي هو ذوي الإعاقة. منو فيك موفر اشتراطات الأمن والسلامة لهم داخل المنشأة بحد ذاتها، سواء العملية أو المنزلية. اليوم مثلا أنت لازم تكون، إذا كان عندك شخص مقعد في البيت لازم يكون في الدور الأرضي. إذا أنت كنت ساكن في عمارة لازم أنت تكون موفر سبل الأمان. أول مكان اللي أنت ساكن فيه في اشتراطات الأمن والسلامة، أن المصعد يكون شغال في حال وجود الكارثة، لأن في هناك مصاعد في حال وجود الحريق تطفي، تنزل على الأرض، تفتح. أما المنشآت الذكية الحديثة فقط مصعد الأطفاء، إذا كانت مثلا نتكلم عن ناطحات سحاب ولا أبراج عالية، فقط اللي هو أسانسير المكافحة أول اللي يصعد عشان ينقذ ما يمكن إنقاذه من الأرواح. فإذا احنا اليوم هم منخرطين معانا في المجتمع، لازم نوفر لهم شرطات أمن السلامة. إذا شخص مقعد في المنزل لازم يكون في الدور الأرضي، لازم الممرات تكون سالكة ما تكون معقدة. لازم أنا أوفر له اليوم العاملين سواء في العمل ولا في المنزل. خلينا نقول احنا اليوم احنا في العمل هني طالعين، منو قاعد في البيت؟ العاملين والعاملات. في كم أحد معلم العامل ولا العاملة رقم الطوارئ كم؟ طريقة إخلاء المكان. طيب أنا عندي إعاقة مثلا حركية، إعاقة ممكن ذهنية، ممكن هذا الطفل ولا هذا ذوي الاحتياج، العامل إذا أنا ما دربت عليه ممكن يؤدي نفسه ويؤدي العامل. فلازم أن أكون هنا على دراية كاملة. يجب تسجيلهم من خلال موقع قوة الأطفال العام، لهم مكافحة يعني خاصة، لهم طريقة تعامل خاصة. طيب احنا نبي نتكلم أيضا اليوم عن في حال وجود الكارثة إذا وقعت لا قدر الله. ممكن احنا شفنا بالفيديو عدة أسباب. أكثر سبب شيوعا في دولتنا هو الحمل الزائد على الكهرباء. الحمل الزائد على الكهرباء باختصار شديد، إذا تبي تقتني منتج عالي الجودة وذكي، مثل ما ان احنا حياتنا قاعد تتطور في التكنولوجيا وفي الأجهزة وفي السيارات، أيضا الأجهزة الكهربائية قاعد تتطور. اليوم الجهاز الذكي إذا حس في اوفرلود ولا خطر شو يصير فيه؟ يفصل. أما الردي الجودة راح يتم يسحب كهرباء مؤدي إلى الاشتعال. فهني نقول إذا أنا بختني أيضا اليوم لازم تكون عندي دراية أني أنا شنو الأجهزة الكهربائية اللي تصل بألياف رئيسية مباشرة، ما يصير على موزعات. الموزع عامل يعني لوقت زمني محدد وينتهي. أن اليوم الغسالة، الثلاجة، الفريزر، الميكروويف، هيتر الماء، السشوار، التلفزيون، البلاي ستيشن، هذا كله لازم بألياف رئيسية. طيب أنا والله بيتي لازم أحط موزع، ما عندي مشكلة، حط موزع، بس أثناء جلوسك في المكان وأثناء أنك أنت موجود في هذا المكان وصلت خلصت من الأمر تفصل. حتى لو كان جهاز ذكي ممكن يؤدي إلى الاشتعال. أيضا إذا ما عندي أنا دراية في المنتجات الكهربائية أسأل أصحاب الاختصاص يتوزع. التماس الكهربائي حصل أيضا من خلال تمديدات العشوائية والوايرات ردية الجودة ممكن يؤدي إلى الاشتعال. وشفنا في الفيديو من خلال الإضاءة كانت ردية الجودة أدت إلى اشتعال مخزن كامل. تسرب الغاز من المخاطر. اليوم الدولة مشكورة مع شركة ناقلات نفط الكويت، خلينا نقول أول شيء عن الكهرباء، ألزمت المباني الحديثة والسكن الخاص الحديث بتوفير اللوحات الكهربائية الحديثة. اللوحات الكهربائية الحديثة هذه شنو هدفها؟ هدفها إذا صار في اوفرلود على المكان تفصل، حماية لك ولأسرتك ولعائلتك أو المنشأة بحد ذاتها. تسرب الغاز الطبيعي، طبعا احنا مثل ما شفنا انفجار في مطبخين مختلفين. مخاطره وين؟ مخاطره ان اليوم شركة ناقلات نفط الكويت ايضا قاعد تتبع اشتراطات الامن والسلامة الحديثة. هوز الطبخ مع منظمة الطبخ لهم تاريخ صلاحية من 3 سنوات الى 5 سنوات ويبدل. حطوا لكم تاريخ صلاحية على الهوز نفسه وعلى المنظم نفسه. إذا ايضا في التطور اللي حصل اليوم في منظمات الغاز نفسها، اذا ما كان راكب عدل ما راح يعمل. معناته ان شنو؟ سيفتي وامان. ايضا خلينا نقول لما نتكلم سيفتي اكثر وامان اكثر، الشول الحديثة والغازات الحديثة اليوم اذا فترة زمنية اشتعلت ما تم اشعالها تفصل. هذه من اشتراطات امن والسلامة اللي تحصل. التصرفات اللي تحصل ممكن اثناء وجود الكارثة ايه هي الخطأ. يعني تسرب الغاز اليوم، الغاز الطبيعي ما له ريحة، غاز الطبخ اللي تشمونه مضاف له ريحة عشان اميز انا، عشان اعرف شلون هل عندي تسرب ولا ما عندي، وين الخطر. التصرف الخاطئ هو اللي يسبب الانفجار. مثل ما شفنا احنا والله الشولة شغالة تسرب الغاز، صار فيه تفاعل ما بين الغاز مع الحرارة الموجودة ادى الى الانفجار. طيب اذا سميت التسرب شنو اسوي؟ اول شيء اذا بفتح باب المطبخ ولا المكان اللي فيه غاز افتحه بطريقة خفيفة، ما المس اي زر كهرباء، لا اطفي ولا اشغل، ما ادش داخل معي الموبايل ابي انا بدق على ابو العيال ولا بدق على الاطفال ولا بدق، ما ادش. افتح البيبان والدرايش، افصل الرأس، اصفي الجو. من يصفى الجو عادة يكون الخلل يا منه في الهوز او في الرأس. ارد اركب اسفنجة معين، امرر على الهوز على الرأس. في فقاعات في تسرب، ما في فقاعات ممكن احد من العاملين ناس العين مفتوحة او احد الاطفال مداش متعبث داخل المكان. وشفنا عبث الاطفال اليوم. الطفل لازم تكونون فيه على دراية كاملة. اليوم الطفل لازم توعيه وتعلمه. رجل الأطفاء، رجل الجيش، رجل الشرطة، المسعف، الطبيب موجودين لحمايته مو لترهيبه. اليوم ممكن طفل واحد إذا طلع برا المكان ينقذ أسرة كاملة. بس إذا أنت مخافة من الشرطة اقعد أنادي لك شرطة الأطفال، اقعد أوديك الطبيب يقزك إبرة، اسكت أوديك المطافي يرشونك بماي. إذا طلع وشاف هذا الإنسان برا يبي ينقذه شنو راح يصير في ردة فعله؟ عكس الكبير. الكبير إذا حس في خطر شو يسوي؟ ينحاش. الطفل إذا حس في خطر ينخش. وإذا شافك أنت وأنت أبوك ولا أمك ولا أخوك ولا أختك برهبينك منه يوم خلاص ما راح فلازم يكون. شفنا احنا خاصة اليوم في التكنولوجيا والسوشيال ميديا والمنتشرة عند الأطفال في مواقع التواصل الاجتماعي المختلفة، ممكن يلقط له فيديو. ممكن هذا الطفل اللي شب الخيمة لاقط له فيديو من يوتيوب، لاقطه من مسلسل، لاقطه من فيلم وحب يقلد. الطفل مقلد في الدرجة الأولى، عبثي حركي، حب اطلاع، حب استكشاف. لا تخوفه، لا ترهبه، دربه، علمه ودربه. إذا علمته معلومات أعطى تدريب على المعلومة. اليوم لازم أنا كل طفل حاط له خريطة إخلاء عند باب المنزل، باب الحضانة، باب المدرسة حاط له خريطة إخلاء، رقم أقرب شخص، رقم الطوارئ، شلون يطلع، شلون يتصرف، ما خوفه. طيب أنا أعطيته معلومات، كثفت له معلومات، حطيتها بمخه، وإذا صارت الكارثة ما عرف يتصرف لأني أنا ما دربته. فهني نقول من الممكن اللي حصل لازم أنا أعلمه وأدربه في هذا الأمر. من الأهمال أيضا ما عندي مطفأة حريق، كاشف دخان، وبطانية الحريق اللي ممكن تقيني من الحرائق اللي لا قدر الله تحصل وتصير. في حال وجود الكارثة ولا الخطر، خلنا اليوم نتكلم إذا احنا عندنا ذوي إعاقة مثل ما ذكرنا، يجب أن يكون الطريق سالك، ولازم أنا يصير عندي العامل أو أنا شخصيا أو الأفراد اللي موجودين في المكان، أول شيء الانضباط النفسي وعدم الارتباك. إذا أنت انضبط نفسيا وما ارتبكت راح تتصرف التصرف السليم، بس إذا أنت خايف ومرتبك ما راح تتصرف تصرف السليم. يعني ليش اليوم دائما سبل الهروب ولا بيبان الهروب دفع؟ ليش؟ ما حد فيكم سأل نفسه سؤال ليش دفع؟ لأن هو الإنسان من دفع. طيب لو أن أنا الحين في هذه الصالة وصارت في حريجة والباب مو دفع ليه داخل، من الخوف والرهبة مرات شنو اللي يوقف عندك؟ التفكير. فلما تبي تطلع شنو قاعد تسوي انت؟ قاعد تدفع، انت تظن ان الباب شنو؟ مسكر، بس هو في الحقيقة الباب مفتوح، بس شنو اللي واقف معك؟ مخك ما يبي يفكر. بالاخير لما انا اكون منضبط نفسيا راح افتح الباب وراح اطلع برا المكان. عشان شي تلاقون سبل الهروب والامان دائما اندفاع. الطفل عكس، الطفل دفاعه انه ينخش. ممكن احنا ايضا ذوي الاحتياجات احد المتلازمة اللي عنده ممكن هو رهبة وخوف، فلازم انا من خلال هذا الشيء انضباط نفسي وعدم الارتباك والتمرين. التمرين مهم جدا اني انا ادرب عشان اعرف ردات فعل. طيب احنا اليوم احنا في الصالة في عندنا عدة طلبة وستاف عمل، فيكم احد يعرف حالة صحية لزميله زميلته طالب عنده؟ فيكم احد يعرف شنو والله زميلتي انا شنو حالتها الصحية، شنو ملفها الصحي؟ ممكن من خلال الحين طيب واحنا قاعدين نطق الجرس ممكن فيها فوبيا، ممكن تشنج، ممكن حالة صرع لا قدر الله، ما أعرف. من خلال التمرين راح أعرف ردات الفعل وأحكمها. لما أنا أسوي هذا الأمر التمرين راح أعرف. طيب العامل عندي في البيت اللي أنا مخليه مع أمي أبوي أو الشخص ذوي الاحتياجات، عارف ردة فعله شنو بتسوي؟ إذا ما دربته، إذا ما علمته، ممكن شو يسوي؟ يهده ويحاش. أنا نفسي هذا موت ما فيها روح النار ما تعرف. ذوي إعاقة، احتياجات خاصة، كبير، صغير، لحظة. وشفنا احنا هي لحظة، إذا ما تداركنا الأمر في هذه اللحظة أدى إلى الكارثة. تحديد نقاط تجمع مهم جدا، حتى معاهم هم لما بيطلع العامل لازم أنا أوديه بمكان آمن وسليم. رسم خريطة إخلاء مثل ما ذكرنا مهم جدا علشان أنا أعرف أقرب مخرج لي، أقرب مدخل لي. أنا دشيت من هذا المخرج صارت فيه الكارثة، أطلع من هذا المخرج. طيب أنا ممكن أقدر أحتوي الحريق اللي موجود في هذه الصالة، وين أقرب مطفأة حريق؟ طيب عندي شخص مصاب، وين أقرب إسعافات أولية؟ من خلال خريطة الإخلاء. هذا مهم جدا حتى في حياتك اليومية العادية. أي مكان تدخل له ركز مكان دخلت منه، وركز على مكان ثاني تطلع منه، لأن مثل ما ذكرنا ممكن هذا المكان اللي دخلت منه صارت فيه الكارثة، ممكن أنا حطيت ببالي مكان ثاني أنا أطلع منه. نقطة الأمان الأولى أني أطلع برا مكان الحريق. نقطة الأمان الثانية أني أصعد السطح. طيب إحنا اليوم إحنا هني في الدور الثاني الأول أيا كان صار حريق في الأرضي، وين نروح؟ نروح السطح عكس النار. ليش؟ إحنا قاعد ننحاش من شنو؟ دخان. 95% من حالات الوفيات اختناق. الواحد يفكر يحترق بس ما يفكر يختنق. النار آفة تحرق كل شيء. الدخان اللي يصعد هذا خطر استنشاقه قاسام إذا دش في جسم الإنسان، والله نجاه يبي له فترة طويلة يتشافى منه، ولكن إذا استنشقته فترة طويلة يعني عمرك الافتراضي 6-7 ساعات وينتهي بعد أمر الله سبحانه وتعالى، لأن رئة الإنسان ما تتحمله. قاسام، حديد، ورق، خشب، صلب، نايلون، كل هذا في الدخان، فما بالك يدش رئتك. هذا من المخاطر اللي نقول تجنب دخولك إلى ما قدرت لا أصعد ولا أطلع عكس النار، أسكر على نفسي باب غرفة، أحط فوط. والبلاغ المبكر هو اللي ينقذك. أول شيء هو اللي ينقذك. كلكم أبطال، كلكم تعرفون تتصرفون، ولكن قبل لا تتصرف ولا تاخذ أي إجراء عشان حتى ما يقع العتب على رجال القوة أنهم وصلوا متأخرين. كثير ما يجينا عتب نلاحظ وقت البلاغ عكس وقت وصولنا. ليش؟ لأنه حاول ما قدر، قام عاد وقال يلا الحين ندق على الأطفاء هم يجون يساعدونا. فنقول أي شيء تسويه قبل لا تسويه أول شيء أبلغ، حتى لو كان حادث بسيط. حتى البلاغات الكاذبة احنا نتعامل معها بشفافية كاملة وبقوة كاملة. عندنا القوة على استعداد كاملا على 24 ساعة ب 24 ساعة. دائما عندنا المراكز مجهزة 49 مركز، وإن شاء الله باكر افتتاح مركزين، بنعدي 51 مركز على أجزاء الدولة متجهين أو موزعين. أقرب أبسط حادث عفوا مركزين عكس الثاني، هذا حاشا مثلا ازدحام، هذا يوصل قبل البلاغ. لما تبلغ معلومات دقيقة خاصة في السكن الخاص، لما تعطيني بلاغ عطني وصف دقيق. آلياتنا كبيرة، دشينا لفة غلط فريج غلط على ما نطلع ياخذ معانا الوقت. هذه مواقع التواصل الاجتماعي لقوة اطفاء العام، واتمنى يتم تسجيل ذوي الاحتياجات الخاصة او المقعدين في موقع القوة مثل ما ذكرنا ان هناك لهم تعامل خاص. في اي سؤال قبل لا نختم؟ الله حياك الله.
جواك الله على العرض. كانت قوة الإطفاء دائما تجي في المؤسسات الحكومية وتسوي لنا تمارين للإخلاء وتمارين وهمية تدرب الموظفين. بدأت هذه التمارين تخف بالمؤسسات الحكومية، شو السبب؟
احنا ما زلنا قاعد نطلع محاضرات توعوية ويا معارض توعوية. هذا عاد يجي دور المؤسسة نفسها إذا هي كانت تطلب أو ما تطلب. أما احنا موجودين. احنا اليوم مثلا معاكم هني عندنا ربعنا مشاركين في معرض مرزام اللي هو في أرض المعارض، وعندنا أيضا حملة. احنا كقوة اطفاء عامة مثلا إدارة العلاقات العامة ما قاعد نستهين، قاعد نطلع. عندنا أيضا حملة البر الحين عشان موسم التخنين، عندنا حملة البر تنطلق إن شاء الله الأسبوع اللي بعده في الأفنيوز، والأسبوع الأخير راح نختمه في 360.
مشاركاتكم بالمؤتمرات أنا أشهد لها، حتى لما كنتوا تجونا في الرياض نشهد لكم فيها. نقصد مؤسساتنا الحكومية.
المؤسسات لما هي تطلب
دائما لما لازم احنا نطلب.
احنا شوف احنا نبادر اذا شفنا الامر. يعني خلينا اعطيك مثال. السنة اللي طافت اطلقنا حملة وقاية وحماية. الحملة هذه كان هدفها نشر الوعي. ليش؟ لأن السنة اللي طافت دشينا بمؤشر خطر. المؤشر شنو؟ عدينا 21 حالة وفاة. احنا هذا 21 حالة وفاة سبت الحريق والقرق، 8 منهم أطفال قرق. فإحنا اللي بادرنا واطلقنا الحملة هذه، بلشناها في المؤسسات العسكرية وانطلقنا على مؤسسات الدولة كلها. فإحنا إذا صار مثل هذا الأمر احنا قاعد نبادر. والله نطلب اليوم من الرئيس مجلس الوزراء وممثلة إنه والله المؤسسات الحكومية يجب أن نعمل نفس المحاضرة التوعية هذه، وأيضا التمرين على هذا. آخر مؤسسة حكومية قمنا فيها بنك الكويت المركزي بالسنة هذه، يمكن محاضرتين أعطيناهم حق فريقين عمل عندهم، وأيضا الإخلاء. المباني أيضا توجه الدولة اليوم في المباني الحكومية قاعد تتحول لمباني ذكية خاصة. يعني نتكلم اليوم احنا عندنا برج الحمراء ذكي، عندنا بنك الكويت المركزي من المباني الحديثة والذكية. كأن مؤسسات الدولة قاعد تنتشر. الأول كانوا مثل ما قلت تشوفوا يطلبون، لا السنة اللي طافت تقريبا قطينا بنسبة 70% من مؤسسات الدولة مبادرة من قوة الأطفال.
بشكرك جزيل الشكر.
عفو.
يعني حقيقة احنا مشهود لكم بكفاءتكم وكل شيء، واحنا متابعين جهودكم العظيمة حقيقة. واحنا بالكلية كلية الكويت وانا باسمها بشكرك على وجودك معنا. هذه جزء من مبادراتكم حقيقة. بس اليوم انا سمعت شيء جديد كمان بخصوص جهودكم باتجاه اخواننا ذوي الاحتياجات الخاصة والإعاقة. فنتمنى ان شاء الله نتواصل معكم نحصل على اذا في اي تعليمات او اشتراطات لتزويدنا فيها. وكذلك موضوع تدريب الموظفين ليكونوا ممثلين يعني قادرين على التصرف الأولي مثل ما حضرتك تفضلت، وكمان إن شاء الله راح يكون بيننا تواصل، وجهودكم مباركة ومشكورة، وأنتم دائما ما تقصرون في أي مجال. فأنا بشكرك باسم جميع الموجودين باسم الكلية على وجودك معنا. مشكور.
واجب. قواكم الله مشكورين.
كولونيل you will be awarded. سيتم تكريم السياسة المقدم من قبل الدكتور رئيس الجامعة.
Yeah, please, just 1 minute summary for our guests and our attendees who don't speak Arabic. So this is mainly a very big initiative that is led by the fire forces in Kuwait in order to basically save lives. A lot of initiatives in terms of the building design, in terms of the access to the building exit, and also a special initiative for people with disabilities. So it's a great effort. And for those who want to know more, they can go to the fire department website and they can get all the needs information. Thank you.
So now let's move to our technical session titled Intelligent Services for Autonomous Digital Accessibility. Presentations today include recent work from Tunisia, Kuwait and KCST research groups covering adaptive recognitive systems, cybersecurity, multilingual assistive platforms, and inclusive smart services. So let's start with our first research paper with Mr. or Madam Ruisi. Okay, adaptive facial expression recognition in the wild with CNN Swim Transformer. So please, on the stage.
Good morning, everyone. And it's a great pleasure to present my work paper, which titled Adaptive Facial Expression Recognition in the Wild with a CNN Swim Transformer, with the professor, Madame Afif Qasim Ashi, and with me, Ruisi Aida, a PhD student from On-Site Lattice Lab at University of Tunisia. So throughout this presentation, I will begin by introducing the problem and highlighting its significance and challenges and motivations. Then I will present the state of the art, and followed by the methodology adopted in this work. After that, I will walk you through the key results and the discussion of their implications. Finally, I will conclude with the potential applications in the future with future directions. Let us first outline the general framework. Our work is situated within the field of emotional AI, known also as affective computing, and emotional recognition from facial expressions is one of the celebrated and challenging tasks in computer vision, particularly in real-world settings. We have the variability in viewing angles is a big challenge in this field, not yet, but the light conditions also and the presence of occlusions, all these reasons affect and conditions affect the capture of facial expressions and distort the performance of recognition algorithms. Emotional AI can detect, interrupt, analyze human emotions during the use and interaction with the new technology through the sophisticated algorithm and deep learning. We are four main modalities of emotion recognition. Physiological, by the heart rate, for example, textual for comments and written texts, behavior from facial expressions, and vocal from intonation and tone of the voice. For my research, I focus on facial expression as they are one of the most reliable and immediate indicator of emotion. Emotion recognition from facial expressions play a crucial role in accessible human-computer interaction and communication, particularly for individuals who rely on assistive technology. The implications of technology are vast-ranging. From healthcare, it can be used in detecting mental health, mixing, or also in security in the system integrated into surveillance or internal camera. And in education also we can integrate some field in the system intelligent tutoring system for detection, for example, the boredom or frustration of children. In marketing also we can integrate this. And thus this is what we refer to as emo-wild. So this slide illustrates a major challenge in emotion recognition from facial expression, and on the left we can see an image can take it or captured in the controlled environment with uniform lighting and well-centered and frontal face, making the facial expressions relatively straightforward. In contrast, as shown on the right, the face is occluded and captured from a different angle, which complicate the analysis of the expression and feature of the face. So the face may be captured from different angles or be partially occluded, which complicate the detection of facial features. The second challenge is the variability of lighting conditions. On the left, we see a dark image, so where facial features are almost invisible, making facial expressions analysis relatively difficult. On the right, we have a case of backlighting. Bad lighting affects the robustness of system. Also, the presence of occlusions and obstructions, such as sunglasses, masks, hand checkers, or caps, or can partially or completely cover the parts of maybe only the face, making facial emotion recognition more difficult. So we main an objective that we design a system can, with deep learning, capable of accurately classifying human emotions in real-world environments. And the model is designed to recognize 7 basic human emotions: sadness, fear, anger, happiness, surprise, disgust, and neutrality. This work builds on the principle of emotion and facial action coding system developed by the psychologist Paul Ekman, which identifies facial muscle movements associated with emotional expression. Deep learning in the recent years has significantly advanced automatically in the facial emotion recognition, and early workers mainly used CNN, convolutional neural network, for local feature extractions, and also some study used exact and global contextual extraction with the transformer, but to address also the classical imbalances and augmentation combined with class weights, all of them apply traditional augmentation with some version of CNN. Hybrid architecture further improved a good recognition for the facial expression in the wild, such as we have some data like RAFDB as so RAFDB, AffectNet, EmotionNet. However, FER 2013 is one of the most complete data sets as it accessible, public, and provides a large number and samples of faces to recognize. CNN-based models alone do not exceed around 75% accuracy on complex datasets, and transformer-based model alone have difficulty in recognizing the fine texture and local features, and the hybrid model combining with transformer and CNN, we have shown a limitation in terms of generalization. So I prepared this solution in my work. I prepared the image before training. For this, I used a pre-processing such as resizing to Gaussian normalization to improve the performance of my model. I also applied specific data augmentation and adjustment of lighting contrast. Then I used a hybrid CNN swing transformer and a swing tiny transformer to classify the 7. So here, and we illustrate the model that has been used in this field. We have the filtering, so we remove the non-facial image and class-specific data. The CNN block personalized to extract the local features, and swing transformer swing for structure and global relations on the face. Finally, we have the classification in 7 emotions. We can see here that this table compares the performance of several facial emotion recognition methods in FIR 2013 and SICA+. And here we have accuracy around 84%. The model thus demonstrates very good overall performance, with the majority of prediction being correct for each classes. And the discussed and Georgia classes are clearly separated and very recognized with a very low classification rate. Here we have some examples and samples for the detection of prediction of in-scene image, natural, and our proposed hybrid CNN swing transformer system achieved around 84% in FIR 2013, which is a significant improvement our previous approaches. So the approach is original and can be adjusted for to different resolution and native RGB inputs on RFGB, for example, around 89%, and FIR 2013 serves as our experimental starting point, and the chosen architecture is flexible enough to adapt to rich and more diverse datasets. The system is fairly complex, defined by a large number of parameters, and may not be easily integrated into mobile systems. An extension of this work would involve processing video to capture to the dynamic of expression of incorporating additional modalities, such as the fusion of facial and vocal information. Thank you very much.
Thank you for this valuable presentation. Any questions? Questions? Do you have the mic? Okay.
Thank you for a very detailed and wonderful presentation. I just wanted to know that how extensible is your approach to video data? So from images, if you have a time series thing, do you have thoughts on extending the model to incorporate video data?
Yeah, exactly. Thank you for this question. First, we have the study is image. So our own inputs are the image, but we have an extension to capture in the sequence video to interrupt, especially in the mobile applications, and in real world, why not, especially in the wild environments, to in controlled settings. It's a big challenge. Thank you.
Thank you.
Any other question?
Thank you for the interesting presentation. I would like to ask a question regarding the training. Is it biased toward faces or objects? And how does that affect to do this on educational or technical images?
So, to integrate this system immediately in the system or education or another domains, we need a data set, have a data sufficiency to learning or training our model and having a good results to train the model. We need especially the context of the domain. So we need the data in the learning, for example, in the system tutorial intelligence, we give the input image to our system and we have the results with the hybrid model.
Sure, thank you.
So thank you for your presentation.
Thank you for the good theme that you treat. I want to ask the question about the scalability of your system and the sample used to experiment your approach.
The experiment approach has been in this. The slide illustrates the training phase of the data, and has obtained performance demonstrated effective learning on and good generalization capability and the validation. And we have the gap of overfitting here. You haven't as we see here. So we haven't a gap of overfitting, and from around the 20th epoch, the losses tend to stabilize and suggestions that the model is converging. So it's performance.
Okay. Thank you.
Thank you again. Thank you very much. So let me invite now Dr. Bassel Al-Othman to present his work, Adaptive Cybersecure Small Doll for Autism Support Emotion Recognition. Please.
Good afternoon, everyone. So I'm very proud of this project because it is my students' final year project. Yeah. Here we go. This is Adaptive Cybersecurity Small Doll for Autism. اللي هنا ناخذ الدبدوب الصغير حاطين فيه أجهزة بسيطة لقراءة التوحد وفهم نوع التوحد اللي موجود. ناخذ منه قراءات بلس يصير engagement بين التوحد ومريض التوحد والادمنستريتورز. هذا باختصار اللي هو مشروع التخرج للطلبة. شنو سوينا فيه؟ So let's talk in English right now so we can speak up. So this is the algorithm that we created out, and we have the input, the child presents. We have the sensors, we have readers, we have the cameras, and we have the outputs with LEDs to give the confirmation. Plus, we have different model to approve it within our framework. Then we have to take real-time interactions between the patients plus the administrators. And we can get a session active, the captured from cameras, to take the movements from the autism patient. Plus, we get the emotions if he's happy or he's sad or he's angry. Okay, this readings we can take it out to collect such data from it. So we are focusing on autism spectrum disorder. This, based on the WHO, they said 1 from 100 children globally, they are affected with ASD. So children often prefer the object of interactions over human interactions as well. Real-time emotional responses, caregivers, which is the administrators within our system, they are limited during the independent sessions, so they can take it remotely. They left it out within their work, and if they are at home, they can connect with them. So our proposed solutions: emotionally intelligent smart doors, real-time eye face trackings. We have LED-based emotion feedback, secure caregivers alerts, and privacy preservative architectures as well. So this is the system architecture overview. As we said, we have LEDs, cameras, indicators. We have cameras and readers, and our algorithm, which is based on Python, and to count and to understand the type of autisms and the need of this autism patient. When we started out within our development with my students, they tried to do the programming stuff, and this is our framework that we start with. We end up with the doll. So this doll, to make it more with the caregivers, plus they understand how they can communicate with them, and they get real-time eye and face tracking to make it more engagement with the students. So we have to make it more secure, because we understand the privacies of let's say the health records. We have to keep it more secure. No one can read it out. No one can see it. So we use different methods to secure it. We give the system testing through the framework. Always we use the SH256 encryptions, which is AES256, which is hash verifications. We did the data transformations between the caregivers plus the administrators, and it's recorded within the patient's the autism records. The right time they can start sending alerts if he's angry or he's hungry. It can send to the administrator or the parents, let's say. So they give this such notification of them. It is based on anomaly detections engines. So when we counted, when we did the programming of our algorithms, it's based on anomaly based. So we simulate users' interaction between the system reliabilities, the detection within the eye orientation with the 2 seconds with the proximity zones while the doors are there. The responded simulations expressions is happy or sad. It gives the LED notification within the doll, plus they can send the SMS messages notification to based on the emotions triage. The logs always stay or saved within the behavior based and in encrypted format. So if the hackers try to collect this data, it is secure, no one can read it out. And that's it for today's presentation. It's about the cyber secure dolls. Thanks. If you have any questions regarding this one, or if you have any ideas to improve this project, I am happy to talk about it.
Okay, thank you. Thank you for your presentation. Just one question. We proposed a solution, but I haven't seen the state of the art of the other solution aligned with your work.
Yeah. So the state of art of this doll is all the transaction is secured, and it is we have the cyber dolls. It communicates between the autism patient plus the doll. so they can make more engagement with the autism patient. Plus, this data this tool understand the emotions of the patient, which is autism based. So they understand the type of the autism. They understand which is more difficult for the, let's say, the GP, the general practitioners, to understand the type of autism before the autism understand it. One more contributions: all this data is encrypted, and no one can read this data, and no one can hack this data except the parties of the engagement of this cyber tools. Thanks.
Thank you, Professor.
Thank you.
Now let me invite one of my best students, Rujdi Al-Dibki, to represent his work Musaid, an LLM-based locally hosted smart home assistant. Please.
So this is the joint work. We'll start. So basically, the main idea of the three remaining papers is to have this as a tutorial, because in this conference we have, the program is comprehensive, but these three papers will come as a presentation around the same topic. It's really good to see the work of Dr. Basil Osman with his students. So these four papers that was presented, the paper that was presented right now, and the three remaining are papers led by students. So as a co-author and working with the students, I just want to make a short introduction. Yesterday, Dr. Mario sent me a note that in China they started to implement a solution, like for PhD students, you don't need to write a thesis, but if you come with a product or a developed solution, then you can graduate with that. These four papers, including the paper that was presented right now, are about providing solution for people with disability using large language models or even small language models, natural language understanding, and essentially it needs to be secured. So I'll be introducing shortly the three students to give them the credit, because they are the ones who did the work. But mainly what I want you to focus on in the three papers will serve all around the same topic. For people with disabilities who don't have an ability, for example, to move or to go to the court, then they do like a solution like Tawkilat is one of the paper, Tawkilat, to do like a power of attorney remotely. Also, there is a solution called Musaid. Musaid, you are connected to IoT at home, and basically you can control everything at home without even moving from your place. That's the power of connectivity. But now what makes this work, the set of work special, or this kind very interesting, is the solution is locally implemented. When we talk about a solution that is locally implemented, then we guarantee the security, the privacy. This information is not shared. So we have a privacy by design, we have a security, and the solution uses LLM and natural language understanding in order to resolve the problem. So I invite our graduate student, engineer Rujdi Al-Dibki, to present his first paper.
So, good morning everyone. I hope all of you are fine and doing well. I am Rujdi Al-Dibki, a former student at KCST, and it is a pleasure to be here to present our paper titled Musaid, an LLM-based, locally hosted smart home assistant for accessible multilingual support. This paper was done by, first I want to thank our co-authors, Engineer Omar Deeb, Engineer Noor Al-Hashash, me, and our beloved doctor, Dr. Ziad Bouida. So, here is a quick review of today's presentation. First, I will start with the background problem background and motivation. Then I will walk through system vision and objective, system overview, AI pipeline and architecture, user evaluation and methodology, performance analysis, limitations and future enhancements. Finally, I will conclude my presentation and give you the opportunity to ask if you have any questions. First, problem background and motivation. As we know, many people or individuals with disabilities struggle in their daily tasks because that technology does not understand them. Even though we have modern assistive technologies and smart home assistants, but still they are not customized to work with or serve these people with disabilities. On top of that, many of these technologies, unfortunately, that still fail to work properly with Arabic dialect, especially the Kuwaiti dialect, so making it or creates a major communication barrier. In addition, most of these technologies, which is the most important thing, they are cloud-based. So families hesitate to adapt them due to serious privacy concerns. So these challenges highlight why we need or a new approach is needed, one that adapts to person needs, one that is private and highlight with the Arabic Kuwaiti culture. And here comes the motivation behind MSAD. So, our vision is to design an assistant that is accessible, culturally relevant, and respectful of user privacy. Our key objectives include, firstly, enhancing independence for people with disabilities, also supporting inclusivity, in addition providing a solution that understands and communicates properly with natural Kuwaiti Arabic. So also our system aligns with the Kuwaiti's Vision 2035 by promoting innovation, inclusivity, and digital transformation. Our system overview. Firstly, our system iterated through multiple was designed through multiple iterations. First, it was initially developed to only respond to people based on patterns, while it worked for simple routines, but it lacked conversational flexibility. So to overcome this, we moved to an flexible, conversational, locally hosted LLM, which is now entirely run on Raspberry Pi 5, and we use the Qwen 3.4b model, which supports Arabic or Kuwaiti natural Arabic. Also, also supports complex instructions. And while all of these done is all private and local. Now, regarding the AI pipeline and architecture, the system used a tightly integrated AI pipeline coordinated by Home Assistant. First, the Whisper model listens to the user and converts speech to text locally. Second, the Qwen 3.4b model interprets the user intent with high accuracy. After that, the Home Assistant acts on intent and interfaces with the connected smart devices, for example, lights and locks. Finally, the Piper model generates the natural sound responses, and all of this is completely offline. It is local and private. This entire workflow, as I mentioned, starting from listening, understanding, acting, and responding, happens without any cloud communication. It is all private, full privacy, and local control. Now, moving on to the multimodal interaction, UI plus voice interface. So to make our system inclusive, we support multimodal interaction. For users who prefer speaking, the microphone interface enables natural voice with no cloud processing, while at the same time we provide a local web UI instead of terminal interface, similar to ChatGPT as shown. Okay, so it gives the user a clean, modern GUI where they can type and interact with the assistant or the system visually. The design ensures accessibility for different user preferences, either voice-based, text-based, or assistive technology-based. Now, user evaluation and methodology. Our مساعد was validated with 18 volunteers with 18 different disabilities. So the users were asked to perform household tasks, for example, turning on or off lights, checking prayer times, in addition to controlling the smart locks. Across all participants, all tasks were done within 3 attempts or fewer. User satisfaction reached an average score of 4.4 out of 5, with participants emphasizing ease of use, comfort, and the most important time, trust, due to the fully local processing, as I mentioned. These results indicate that مساعد offers a reliable and empowering experience. Regarding the performance analysis, in terms of performance, the total end-to-end response time as shown is 1.8 seconds. This is fast enough for natural conversation flow, but and it is also faster than other large models, for example, models that use 8 billion models, but it will have some limitations that we will mention in the next slide. So while not instantaneous like cloud assistance, it represents an excellent balance between speed and privacy for local edge processing. Also, it produces 5 tokens per second, enabling flood and coherent replies. Now, regarding limitations and future enhancements, of course, like any system, مساعد has limitations. The 1.8 second latency is good, but not fully real-time, since all the model is local. It cannot access live information and updates. Additionally, running the LLM continuously consumes more power than traditional standby smart devices. For example, if we run for 24-hour all day, or all days, it will consume high power. For future enhancements, we plan to add a local RAG pipeline to provide real-time knowledge while preserving privacy, or making everything local. We also aim to integrate gesture recognition, eye tracking, healthcare connectivity with government systems, and support for smart wellness devices such as the Oura Ring, in addition to medication reminders and caregiver connectivity, will further enhance users' independence. To conclude my presentation, مساعد demonstrates that powerful AI can run entirely offline. Also, it provides culturally relevant Kuwaiti dialect communication while ensuring completely privacy. It enhances independence for users with diverse needs and offers a promising future model for accessible, inclusive, and privacy-first AI. This is for today's presentation. Thank you for your attention. I hope you enjoyed our presentation.
Thank you. Mustafa.
Thank you, Rushdie, for the interesting presentation. Although you were really indeed a very good student, that does not mean that I will not ask you questions.
But we make a deal. If I don't ask you in your conference presentation, you will not ask me.
That was I was the first because I don't want to do this deal. Regarding the robustness, did you do any robustness test on your system? I mean, did you give it any complex tasks and check the latency?
Actually, no, we didn't do like complex tasks. It was like the easy task, turning on/off lights and like checking prayer times. So it was the small tasks, and as I mentioned before, like the response time was 1.8 seconds. So no any complex tasks was done, and it is still like a prototype, and we are still only trying. Yeah.
So when you compared it to a larger LLM system, you use the same commands for both of them, right?
The same
commands or requests from the system.
Yeah, we use the same commands, but it is still faster than the
LLM.
Larger LLMs that use 8B model.
Great. Thank you.
Thank you. Alhamdulillah, it was an easy question.
So let me now invite one of our best students, Omar Deeb, the superstar. So to make a presentation of his paper, IHJZ, Multilingual Voice Driven Reservation System. Please.
Okay. Thank you, Dr. Abdul Latif. Okay. Assalamu alaikum. This is Omar Deeb, the ex-student ambassador at KCST. I'm presenting this paper, although one of our clients just got hacked today morning, alhamdulillah, and I have to go to fix their stuff at evening. So, I'm presenting IHJZ, which translates in Arabic to make a reservation. The project represents a system-level innovation. The project represents a system-level innovation we have built in a multilingual voice-driven reservation system designed specifically with an accessibility-first architecture to serve disabled people. Today, I will show how we prioritize privacy and lightweight engineering to bridge the digital divide. So, our main problem that we faced when we looked up all other projects regarding the services industries, we found that there is a huge accessibility barrier. Digital transformation in service industries often prioritize complex graphical user interfaces, which creates unintended barriers for individuals with visual motor or cognitive limitations, effectively locking them out of essential service. When we looked up also the current voice AIs, existing solutions like Siri or Alexa often fail in a critical accessibility context. Lack of deep integration with real-world service workflows, rigid and natural command structures, and insufficient support for Arabic dialects and cultural nuances. So, now with our methodology. Here is the core hypothesis of our research. The current standard in AI use massive transformer models like BERT running on the cloud. They are accurate, heavy, battery draining, power intensive, and require sending your voice data to a third-party server. We argue that for accessibility tools, privacy and battery life and power consumption are more important than marginal gains in accuracy. Therefore, IHJZ uses a lightweight client-side architecture, which with couple of features as offline service that runs efficiently even on low-end devices like IoT devices in region with poor infrastructure. For our system architecture, I used a brain and muscle architecture which is inspired from Dr. William Wolf, we are not related by the way, on Hydra OS in the 70s. I was looking up his work, and it's an amazing work. I advise you all to read his work on early stages on operating systems. Anyway, to achieve this, we designed this architecture as a front end, the brain. This is a simple client-based React application developed by me and Rushdi, Jazallah khair, to capture and synthesize directly via web search API, which ensures zero voice data transmission to the cloud. Yeah, okay. For the backend, the muscle, we decoupled microservices including the natural language understanding processor and reservation manager, abstract complex booking logic, allowing business to integrate without infrastructure or overhaul. Okay. Now for the technical implementation, we optimized the NLU pipeline where we differ from big tech. Our main difference that we don't depend on heavy deep learning models. We use a hybrid approach. We use SVM, support vector machines, for understanding intent, and CRF, conditional random fields, for extracting details like time and date. The results is as shown in the key advantage below. The interface takes only 12 to 23 milliseconds. The model is just 5.3 megabit, allowing for offline capability. It consumes 15 to 40 times less energy than transformer models, which is critical for mobile users relying on battery power. Okay. Processing Arabic presents unique challenge due to its morphological complexity and dialects. Our pipeline addresses this with a signal processing component. We use Wiener filtering for noise reduction and MFCs to extract features from the voice waveform. And we use UI adaptation based on WCAG recommendation 2.1 AA. The interface automatically switches between left to right and right to left layouts, depends on the user speaks Arabic or English. The reservation workflow. So let's take a walk through a user journey. The user says, book a haircut tomorrow at 3 p.m. The transcription is the browser converts speech to text locally. Then the analysis, the NLU pipeline, our backend, the muscle, identifies the intent, like make reservation, and extracts the entitles, haircut, which is the service, and the time, which is tomorrow 3 p.m. Then we do the action. The system checks the database, books the slot, and generates an audible confirmation. If information is missing, the dialog manager will ask a specific clarification questions. For implementation and security, robustness is key for accessibility. Offline first, we used indexed database to save the conversation state locally. So the user does not lose their progress. They can continue once they are connected back to the internet. For security, we use a privacy by design by processing the NLU on the client where possible and testing TLS 1.3 for transmission. We minimize the exposure of sensitive voice data and transferring the request. For results and conclusion, here is the performance evaluation metrics. So, how does it perform? We achieved an intent accuracy of 95.2 for Arabic, crucial in our developer-led functional tests, where we successfully completed full reservation dialogues. We hit a 91.5 success rate. The system responds in under 500 milliseconds, providing a near real-time conversational experience. For comparative analysis, we compared to market leaders, like Google Assistant or Alexa. While they are generalists, we are specialists. Ihjaz wins on the privacy because of its client-side nature, and Arabic accessibility because it's specifically designed for compliance with the Arabic version of WCAG 2.1 AA standards. We fill the gap that mainstream tools ignore. For limitations and future roadmap, we want to be transparent about limitations. Currently, our validation is developer-led, basically me. We have not yet conducted any formal user studies with disabled participants. Also, browser support varies because Firefox does not support polyfills natively. So we need to integrate a third-party polyfill for such a feature. This will allow the entire AI to run offline in any browser, removing our dependency on any specific AI. In conclusion, Ihjaz proves that you don't always need to be massive on the business scale, or you don't need massive computing power to be inclusive. By prioritizing architecture over raw algorithm size, we can build tools that are private, accessible, and efficient. We are proving that accessibility and efficiency are not automatically exclusive. Thank you, and any questions? Mustafa, do you have any question? Please ask. أحسن لك هربت. Okay, thank you.
So finally, let's invite Osman Al-Zafiri to make a presentation on his work, empowering digital autonomy via e-accessibility, توكيلات. Please. Which one? Yes. This one. Yes, yes.
Hi, good morning everyone. My name is Uthman. Today I'm presenting Tawkilat, a blockchain-based power of attorney system designed with e-accessibility in mind. A project designed by Amr Deeb and I, supervised by Dr. Basel Uthman. The goal is to let people create and manage power of attorney digitally in a secure and verifiable way, especially users with with barriers and disabilities, traditional in-person process. Power of attorney services are still often slow and paper-based for elderly users and individuals with disabilities. The requirement to be physically present can become the main obstacle to autonomy. So the motivation behind Tawkilat is to replace a cluttered bureaucracy with a streamlined accessible digital process that still maintains legal trust and integrity. We define the problem in three parts. First, physical barriers. Mandatory in-person steps can exclude people with mobility challenges, and even social anxiety can make these procedures difficult. Second, procedural delays. Paper trails are inefficient, prone to manual errors, and slow to process. Third, trust deficit. Traditional documents can be altered, lost, or used under coercion, and they often lack an immutable, verifiable audit trail. So overall, we need a solution that supports remote access while strengthening verifiability. When we look at related work, some approaches use digital signatures to improve efficiency, but they often still rely on centralized databases. Some blockchain approaches exist mostly as a specification or theoretical proposals, without a working end-user product. And in practice, traditional power of attorney remains heavily paper-based. Tawkilat advantage is combining a working mobile prototype with decentralized style verification and a strong focus on accessibility. Now here, the system overview. Tawkilat involves three roles: the principal who grants authority using the mobile app, the agent who receives the digital power of attorney, and the like a bank or a government agency that validates the power of attorney before accepting actions. The system is mobile first for accessibility, backed by a private blockchain signatory registry and smart contract logic that automates the power of attorney lifecycle. In terms of user flow, the interface is designed to reduce cognitive load and keep tasks simple. Users log in securely and minimal friction, And we integrate digital identity verification using mobile Kuwait app for dashboard. The principal can quickly see which delegation are active and which ones are revoked. So control and visibility are always clear. A key design decision is privacy by design. Through a hybrid architecture of chain and SQL, we store personal identifiable information and raw document, which also supports requirements like right to erasure. On chain, we store only cryptographic hash using SHA 512 and transaction metadata that gives immutability and verification without exposing sensitive data on the ledger. The important point is that if the document changes by even one character, the hash changes and verification fails, so integrity is protected. توكيلات manage a power of attorney through a secure state machine that status is valid and checkable at any time. The power of attorney starts as a draft when created by principal, becomes issued once it is signed and anchored on the blockchain. And it's active while it remains valid and within its expiration date. The principal can also revoke it explicitly. This makes the verification straightforward, consistent, and auditable. Accessibility is a core outcome of توكيلات. We align with WCAG 2.1 AA principles to ensure usability for all users. Perceivable design through high contrast and large touch targets and understandable design through simple non-legalistic terminology and robust compatibility with the screen readers and assistive technology, in parallel with secure legal transaction using multi-factor authentication for signature, non-repetition through blockchain records, and SHA 512 hashing to protect documents integrity. So توكيلات aims to combine user empowerment with strong security guarantees. Implementation wise, توكيلات uses .NET UI for cross-platform mobile development, so app can deploy in both Android and iOS from a single code base. The backend is built with ASP.NET Core to handle user request authentication and database interaction for ledger layer. We use SQL with cryptographical verifiable centralized ledger model to provide a blockchain-like structure in a controlled private environment. To evaluate the real-time readiness, key operations were tested across 1,000 iterations in a standard development environment. Hash generation is essentially negligible. Block validation is effectively instantaneous, and the anchoring or mining operation average about 131 milliseconds. That indicates the system can support responsive real-time user experience while maintaining verifiability. To include توكيلات removes physical barriers to legal autonomy through a secure hybrid blockchain solution that is accessibility first and privacy aware. Looking forward, the roadmap include moving toward distributed consonants such as migrating Hyperledger Fabric, adding strong biometric binding like Face ID or fingerprint, and performing a full legal framework analysis including DAS compliance. Thank you for listening, and I'm happy to take any questions.
Any question, please? No questions? So thank you, Osman. Thank you so much. So I thank all speakers for their insightful and valuable presentations, and all speakers are invited to the stage to be awarded by the president of our university, Professor Khalid Al-Biqain. So please to the stage. Mr. or Madam Aida Ruwiti. Dr. Bassel Al-Othman. Mr. Omar Dib. Rushdi Al-Dibki. And Osman Al-Zafiri. Salwa Miryahi. And finally Kawthar Kabi. صورة جماعية. So now I invite Professor Muhammad Atrabilsi to the stage to start the closing ceremony.
لا ارتاح شوي بعدين نديك ارتاح شوي استنى اختلف مني لا سامح Drive. Yes. So, ladies and gentlemen, dear colleagues, dear students, Assalamu alaikum. So before we proceed with the much awaited award segment of our program,
So please allow me a few moments to reflect on this inspiring and vibrant gathering that we all have been part of during this week. So as a conference chair, I am truly proud to witness the remarkable growth and impact of the second edition of ATSN. So this year marks a significant milestone where ATSN is collocated with the 10th edition of the International Conference of ICT and Accessibility, ICTA 2025, a synergy that has clearly elevated the visibility, reach, and academic rigor of the event. So this year's edition has attracted substantial interest from the community. We received 65 research submissions, out of which only 25 high-quality papers were accepted and presented during the conference, reflecting an acceptance rate of less than 40%. So this selective acceptance rate is a strong indicator of the seriousness of the review process and the merit of the accepted contributions. So over this week, we proudly hosted 25 technical presentations, delivered both online and in person, 7 inspiring keynote speeches, 4 engaging panel discussions, 5 amazing and very interactive workshops with more than 130 participants, and a vibrant poster exhibition showcasing over 40 posters from KCST and researchers across Kuwait. So before we move to the award segment again, so I am kindly asking Sayyida Maryam Al-Kandari, yes. Sorry, just last minute change. Just maybe before announcing the awards and before announcing the best paper award and the best poster winners, maybe call Dr. Ziad Bouida as program chair to talk about the review process and about evaluation of the best paper award. Dr. Ziad, please.
Thank you so much for all who stayed until the end of the conference. So what makes this conference special, I mean, especially that what Professor said about the growth of the conference, is the effort and the synergy with all our collaborators. We got the chance also to expand our collaborators by having Dr. Mario here and all new partners, and we hope to have them for the future editions of the conference. Now coming back to the technical program, I don't want to repeat, but 65 papers, we ended up accepting in the beginning 30 papers. But we made sure that we don't accept the paper as is, so we accepted also paper with major revision that needs to be done. Unfortunately, although the quality of the papers are very good, once the paper needs major revision, we didn't accept those papers. We also rejected some papers with possible resubmission. These are papers that the topic is very interesting, but it cannot be accepted at the present format. So this needs more than major formatting and changes. Now, when it comes to the 25 papers, we extracted 10 very good papers. All the papers are excellent. The topics are very interesting. Now, when it comes to different criteria to decide on the paper, we needed to filter again. We finalized shortlisted like 10 papers. We sent them to five colleagues, and even externally, 1 from Canada, 1 from Qatar, and 3 from here. And we received the feedback about the process. And there is kind of an agreement. The best paper was selected like the first in 3 were selecting the first, 1 selected as the second, and it was selected as the third by the fifth. So we also, the paper received a very good feedback during the presentation. It's basically the novelty was really clear, and it doesn't mean that the other papers are not novel, but it was an incremental or even major. All the papers are great, but again, to conclude, that paper especially, it tackles a very interesting problem, and it has a major contribution to the field of sign language. I gave a hint now about the paper. So that's what basically happened in terms of the process. We can honor basically again the quality of the papers are great. While waiting for Professor Trabelsi, I want to take an opportunity to thank all of those who contributed to either the review. We have reviewers from Kuwait and outside Kuwait, and also we have the technical program committee, without mentioning names, they will be mentioned later, but who basically went through the papers again and again. A quick idea of how IEEE publication works. So we receive the paper, we do the reviews. Once we have the final accepted papers, it's not published yet. They need to present, and we made sure that all the papers are presented. We also made sure that the papers are revised. So we send them the first round of revision to have kind of final version, but we need to verify it. We send it to the team of Professor Jimny also for the ICTA process. I take the opportunity, quick last note, to thank the team from Alexo, including Engineer Bilal, for the great work done for the last months of communication. And last but not least, we have Dr. Usama Al-Ghul, who did tremendous work on building the platform and the review process, and we are still working together on sending the final versions of the paper. Thank you so much.
Thank you very much, Dr. Ziad. So that was mainly related to the review of the paper and the selection of the best paper award. So now I'm kindly asking Dr. Omar Adam to come on stage to also to give you some remarks and some information about the poster evaluation. Dr. Omar.
Thank you, Professor Trabelsi. So in this ATSN conference, we had the typical poster competition, which is basically a call for the ATSN-related posters that concerns the assistive technologies and topics that cover this area as well. We received a total of 45 posters. 43 has been accepted, and one was out of the scope that we had to reject. And the second one was requested to do a minor revision regarding the formatting of the poster, but we have not received this, so we had to reject that poster as well. So we have a total of 43 posters accepted. The majority of these posters are student work, and a total of 3 they have been external posters from authors that are not local to Kuwait. And with regard to the review process, we have a total of 5 grading rubrics that we assess all the posters based on, and we've been able to finalize the final list of winners, and we've got 3 top posters based on the evaluation that we have concluded at the end of this conference. We did notify the winners. I hope they are somewhere here on this hall, and all the posters, they have been of very interesting topic. They cover interesting problems related to assistive technologies, and we hope to see this participation from future students as well as interested authors in this domain of technologies. And yeah, that's all I have now. Thank you.
Thank you, Dr. Omar. So as you have noticed, we try to be transparent as much as possible. So now I will kindly ask سيدة مريم أحمد الكندري نائب رئيس مجلس إدارة الجمعية الكويتية لمتلازمة داون للحضور المسرح to say a few words about the conference. Please, سيدة مريم.
الرحمن الرحيم. البروفيسور خالد البقاعين، رئيس كلية العلوم والتكنولوجيا. تتقدم الجمعية الكويتية لمتلازمة داون لشخصكم الكريم ولجميع أعضاء الكلية الموقرة أطيب التحيات والتمنيات بدوام التوفيق. فإن الجمعية قد أسعدها دعوتكم الكريمة للحضور والمشاركة بالمؤتمر والملتقى الدولي الثاني للتكنولوجيات المساعدة لذوي الإعاقة. وقد كان لمشاركتنا ومشاركة أبنائنا من متلازمة داون لمعرض عمق اللون أثر كبير في دعم وتمكين هذه الفئة بجانب تعزيز الوعي وتقديم الفائدة، حيث كانت فرصة ثمينة للاستفادة من الخبرات المتخصصة والتعرف على أحدث المبادرات التي تخدمهم. لذا وجب علينا توجيه خالص الشكر والامتنان لكل من الفنان الأردني الدولي سهيل بقاعين، والدكتور شبلي جمعة، والدكتور محمد فيصل ناجي، والدكتور باسل العثمان، والمهندسة زينب أبو الحسن، والمهندسة هاجر الصليلي، والمهندس عيسى ودعان، والسيدة ماركيزة الغنى، والسيدة عبير عمر، والسيدة أميمة سلمان، والسيد أسامة حسام، والسيد ماقيش بوثامبور، والسيدة عليا أبو عيشة، والسيدة لارا الصباغ، والمهندسة نيفين جلال، والمهندسة مريم فواز، والمهندسة فرح كوراني، والسيد سيفين بياس، والطالبة غالية الحجرف. ذلك لما لقيناه من حفاوة الاستقبال وكرم الضيافة وحسن التعامل الذي عكس أسمى معاني التعاون والاحتفاء. لقد تركت مبادرتكم أثرا طيبا في نفوسنا، وجسدتم بأفعالكم روح الرقي والإنسانية. شكرا لكم جميعا، ودمتم كما عهدناكم نموذجا للعطاء والاحترام. وشكرا جزيلا دكتور خالد، وهذه هدية بسيطة. يعطيكم العافية.
تفضلي أستاذة مريم. Okay, so now finally we'll move to the award segment. So I'm kindly asking Professor Khalid Al-Baqaeen, the President of Kuwait College of Science and Technology, and Professor Muhammad Jimni, the head of the ICT at Alexo, to join me on stage to present a token of appreciation to the key success partner of this event. We'll start by recognizing our strategic partner, Lati's Lab, presented by His Excellency Professor Imad Jabri. Please join us on stage. Yeah, please, Professor Imad, please remain on stage. So I'm kindly asking Engineer Naif Al-Awadi from Kuwait Information Technology Society. Is he here? Dr. Basil Uthman, he will take the token of his behalf. Engineer Muhammad Ashkanani, representing W3C GCC chapter. I think Dr. Basili will be taking again the token on his behalf. Thank you. So now we'll give a token of appreciation to the dedicated members of the KCST organizing committee. I will start first with Dr. Ziad Bouida, whose tireless dedication and efforts have been instrumental in shaping the success of this conference. Dr. Muhammad Naji, whose dedication and impactful initiatives have been key to the conference success. Thank you, Dr. Muhammad. Dr. Abdul Latif Baba. Professor Murugapan. Professor Abul Fadl. Dr. Ahmed Arafa. Dr. Omar Adam. Dr. Murad Khan. And Dr. Basim Al-Halawani. And now, it's with great excitement that we come to the moment you've all been waiting for. Time to announce the winners.
أكاديمية نور حبت تعمل إشي لإلكم. هذا طباعة طلبتنا. أول إشي شعارنا طبعا بأكاديمية نور شعاركم. لكن الإشي المميز في الموضوع هنا اللي هي ورقة النعنع. ورقة النعنع لأنه هم لما إجوا لونوا في عبق اللون كان اللون الأخضر ريحته نعنع. فحبينا نعمل اندماج وهذا من طلب. طبعا احنا دائما بنقول نحن ننتمي الى هذا العالم ولهذه الارض وكلنا انسان. الفنان بس مشي واحنا كنا الله يحفظك يا رب. وشكرا كثير بالنيابه عنكم جميعا. انا صح مؤسس ومدير عام اكاديميه نور، لكن انا ام لمتلازمه داون، والوقفة اللي كلكم وقفتوها بحضوركم أو بالمحاضرات اللي أنتم عملتوها يعني يعجز اللسان إنه يحكي فيها. فشكرا كثير 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 لكم.
So now it's time to announce the best poster award and the best paper award. So for the best paper award, in the third place, best poster award, the third place. Some excitement or no need? We don't have time. Immersive VR training for neonatal emergency response, authored by Badr Al-Khalifi, Haya Al-Hajri, Sheikha Al-Bathali, supervised by Dr. Huda Al-Rashidi. Is there no one from the winners is here? Okay. Second place, it goes to Gesture Recognition Smart Blues for Sign Language Interpretation, authored by Arwa Al-Ajmi, Rayan Al-Zahir, Anfal Al-Gallaf, supervised by Mr. Farid Jaradi. And the best poster award at the first place. So the winners are Hajar Ubaid, Awrad Al-Anizi, Nouf Al-Mtiri for their work entitled Aoun, Smart Assistive Glasses for Alzheimer's Patient. This work has been supervised by Dr. Muhammad Naji. Dr. Muhammad. Yeah, where are they? Only one. Yeah. We did. Thank you. So finally, I'm asking everyone who contributed to the success of ATSN and ICTA, so please join us on stage for a big family photo. Please, come on stage. Everyone, please. Whoever contributed to the success of the conference. Engineer Bilal, please. بعد خمسة. لا صحيح. Yeah, I will announce. وين زياد؟ الله يعافيك، تفضل. انجينير بلال. Yes, so yeah, I intentionally kept it to the end because unfortunately the winner of the best paper award is not among us, so there will be no token of appreciation. Just I will announce it here. So the best paper award goes to Vision Alt Score, Large Scale Automated Quality Grading of Web Alt Attributes by Dr. Hind Al Khalifa from King Saud University. So we'll make sure that we'll send her the certificate by email. Thank you very much and see you next year, inshallah. Yeah, please join us for the lunch, as usual, in the library, second floor, right? Thank you so much. مركزة بعد ما تتصور معي